Welcome and good morning. We start with an early morning presentation of abstracts, and we have 3 talks. They should be 20 minutes each, so we can have a 15 minutes Q&A. And our first speaker is Yorgos Figas, and presenting work with Katerina Canavari. And the talk title is Aristotle and AI, from the dialectics of being and thought to reflecting on automata and the camera obscura. The floor is yours.
Okay, thank you. Okay, can we have the slide shown on the behind, please? Okay, thank you. Thanks a lot. Okay, so I'm Yorgos Figas, and my co-author is Katerina Canavari, and I'm going to talk to you about Aristotle and AI, of course, the theme of the workshop. The title is From the Dialectics of Being and Thought to Reflecting on Automata and the Camera Obscura. Automata have been referred to a couple of times before in this workshop. I hope I'll give a slightly different view in this talk and talk about some other things as well. So, Aristotle, so Aristotle, the great thinker of the antiquity, has had contributions on truly a diverse range of topics, including politics, ethics, and numerous fields of science. Out of those, connections to the modern understanding of artificial intelligence can be traced in, again, numerous ways. This symposium is a testament to this fact. In this talk, we shall discuss this possible tracing in terms of 3 distinct paths within the work of Aristotle. First, regarding his contribution regarding automata and labor. Second, regarding Aristotle's position as a staunch believer in approaching the truth through observation and experience. We note a parallel related instance in terms of the controversy between data-centric and model-centric approaches. Third, we mention Aristotle's contribution on the theory of optics, vision, and his observations regarding effects related to central projection and the camera obscura. This aspect of Aristotle's thought is implicitly related to AI, as vision, computer vision, as an evolving field, has had traditionally a very close relationship to pattern recognition and machine learning, hence artificial intelligence as a whole. So, the first part, automated machines and labor. In Politica, the philosopher states, for if every instrument could accomplish its own work, obeying or anticipating the will of others, like the statues of Daedalus or the tripods of Hephaestus, which, says the poet, of their own accord enter the assembly of the gods. If, in like manner, the shuttle would weave and the plectrum touch the guitar without a hand to guide them, architects would not require the use of servants, nor masters would have need of slaves. The most important point here is perhaps not that Aristotle is making reference to automated machines. Mrs. Kinty yesterday pointed out that, in fact, part of this text comes from the Iliad, for example. Besides, similar references exist in Greek mythology with tales shaped long before Aristotle's time. Another example is Talos, the mythical automaton that was charged with guarding the island of Crete. Even if noted under a hypothetical form, he speaks about machines that could, in particular, replace man with respect to his being as a worker or as a generator of labor. Hence, he puts forward a substantial difference in comparison to machines that merely exist as organa ποιητικά, means of production, which presuppose active participation on behalf of the human counterpart. So, for the contemporary reader of the Politica, a juxtaposition of this idea to the modern notions of artificial intelligence and artificial general intelligence, AGI, is virtually inevitable. Artificial intelligence, as a scientific field, dates back to the works of pioneers such as Alan Turing, McCulloch and Pitts, and Frank Rosenblatt, with work as far back as the middle of the previous century. Artificial general intelligence is a much more modern term. Its differentiation from the previous notion is in terms of scope. AGI is understood as a type of AI, non-existent yet, that will be able to solve a diverse range of problems at a superhuman level of efficiency. Much controversy has been generated with respect to AGI, with top researchers in the field routinely being asked to produce estimates on how close or how far are we from AGI. See, for example, the proceedings and invited talks of top AI conferences, such as the International Conference on Learning Representations, or NeurIPS and others, which included talks in this exact theme. Regardless, the core idea in both terms is machines that will be able to carry out tasks that are non-trivial enough to be characterized as requiring intelligence. The complete retraction of the need for a human worker and his replacement by the Dalek automaton, the weaving loom that weaves by itself, or the guitar that plays its song on its own, is perhaps conceptually the closest counterpart to these contemporary notions that the antiquity has put forward. In the previous excerpt, the architecton will concoct the general plan of the desired outcome with no need for leaving Ipirete. This point is especially noteworthy with respect to parallels to the contemporary scientific status and social being. For Aristotle, it seems natural that the existence of machines that would, in today's terms, be considered intelligent must lead to the consequence of the complete abolishment of the necessity of labor. Ουδέν αν έδι ούτε της αρχιτέκτωσιν υπηρετών ούτε της δέσποτες δούλεν. Meaning, architects would not require the use of servants, nor masters would have need of slaves. So, on the note of the largely of dystopian nature impact that goes together in estimates and predictions over the evolution of AI, we believe that this particular societal dimension of the philosopher's thinking should be the basis for a broader discussion and consideration by experts and laymen alike. Before proceeding, let us close with a note. An interesting relation of the aforementioned passages concerning human labor with respect to Aristotle's analysis of economics has been outlined centuries later by Karl Marx. He says in the very first pages of the first volume of The Capital, "Let us go back to the great thinker who was the first to analyze so many forms, whether of thought, society, or nature, and amongst them also the form of value. I mean Aristotle. Aristotle, therefore, himself tells us what barred the way to his further analysis. It was the absence of any concept of value. What is that equal something, that common substance, which admits of the value of the first commodity, beds, being expressed by a second commodity, here house? Such a thing, in truth, cannot exist," says Aristotle. And why not? Compared with the beds, the house does represent something equal to them, insofar as it represents what is really equal, both in the beds and the house, and that is human labor. So let us pass to the second point in relation to Aristotle and AI, which is being and thought. Being and thought and its instantiation as data-centric versus model-centric models. So, any philosophical model should, be it explicitly or implicitly, answer a fundamental question. Given the dialectics of being and thought, matter and ideas, which one is primordial? Which one comes before the other, so to speak? Matter or ideas? Given this divide, we can define a partition of philosophical thought into materialism and idealism. Aristotle has criticized severely Plato's theory about ideas. In Metaphysics, he asserts that the Platonic ideas end up in multiplying the intellectual labor that is required to explain reality, instead of aiding to facilitate the process. In particular, ideas double the number of notions that demand a rational explanation. For Aristotle, the essence of things lies within themselves, and within themselves only. In this sense, the ideas of the idealist philosophers and the ideas of Aristotle clashed. See, for example, the beautiful depiction of this collision of ideas in the School of Athens of Raphael. An interesting example related to the point in question is Kepler, many centuries later, of course. Initially, he tried to force a Platonic-inspired model as a model for our planetary system. The distances between planets were to be determined according to a model that was to adhere to a system based on the properties of the so-called Platonic solids, i.e. the set of regular polyhedra. The correct solution for Kepler, however, only came forth when he really took advantage of his data. Only after taking into account an extensive data set containing very much detail, at least in comparison to prior data collections, based on decade-long observations by astronomer Tycho Brahe, as well as including a stroke of genius, of course, by Kepler, he could come to the correct conclusion. In particular, circular orbits and Platonic solid-based models should be ditched for good. The data, i.e. the observations, simply pointed out the truth, which included the laws of Kepler, the laws of Kepler that we know today, and the elliptical orbits and so on. That is known and accepted today. So, today, this position of Aristotle finds confirmation within some of the fundamental notions in data science and machine learning. Over a series of practical problems, the best solution is shown to require taking advantage of observations themselves, data themselves. Perhaps the most widely known application of this idea is related to large language models. ChatGPT, DeepSeek, etc. Billions of data samples, natural language sentences, scraped to a large degree off public repositories, form the input raw materials with which AI is running. The general form of the AI model itself, in its modern deep learning variant, can be used in a diverse range of problems, with a prime difference between applications being the quality of type of input data. The premise of machine learning is indeed that using extensive observations of the reality of the problem at hand will lead to a better solution than any handcrafted modeling of reality, no matter how well crafted it is, if it does not use data to fine-tune itself. Hence, in a way, it is a clash between the material world and the world of ideas, and it is matter that leads to the best solutions. In reference to an axiom of dialectics, we could also state that the quantitative plethora of observations, data, translates to qualitatively superior characteristics. And on the last part, about vision. AI, since its very beginnings as a distinct field of computer science, is intertwined with the evolution of the field of computer vision and image understanding. In Aristotle's work, we can find a diverse set of stated problems regarding the nature of optics and image formation, as for example in perichromaton, de coloribus in Latin, or in problemata, problems, and elsewhere. In this image, we see an implementation of the first neural network, in fact, the so-called perceptron. This is from the 1950s. It was initially built with the sole task of image recognition, a computer vision task. And in fact, a central problem in modern-day computer vision as well. In Problemata of Aristotle, we read, why does the sun penetrating through quadrilaterals form not rectilinear shapes, but circles, as for instance when it passes through wicker work? Is it because the projection of the vision is in the form of a cone, and the base of a cone is a circle, so that the rays of the sun always appear circular on whatever object they fall? This excerpt goes on with forming a set of similar problems, followed by argumentation and attempts of explanation. Aristotle is interested here in studying what is today called image formation, or broadly the dialectics of 2D image and 3D space. Even though his analysis is far from being considered complete or accurate by today's standards, what is important is that he is forming a recommendation that is integral as groundwork for the contemporary fields of photogrammetry, vision, and computer graphics. He describes correctly light source rays as straight lines that lay in space. He says, και αυτέ ευθεία εισιν, and is alluding to elements of central projections, ως περδιοπής εάν λάμπει ευγονείο το φως. However, a major obstacle in forming a correct theory is his hypothesis that vision manifests itself through optical rays. Sorry, yes, through optical rays. Through optical rays that depart from the eye, beginning from the eye, and towards the objects, a hypothesis that will in fact be corrected only centuries later. Perhaps unexpectedly and quite interestingly, this reverse trajectory will be, in a sense, a fundamental aspect of the modern ray tracing technique in computer graphics. An outline of which we see in this slide. Very broadly used, indeed, today. Yeah. So, yeah, and this concludes my talk. Thank you very much for your attention. I would love to hear your questions. Thanks.
So I think it's better to take the questions after each talk. So it's you remember the questions actually. Okay. So we have something like 6-7 minutes for questions.
So we ask the question.
Yeah. I mean, I think it's a better format.
Or yeah, maybe after on the coffee. Yeah.
Antonis?
Yes, please.
Yeah. So, thank you very much. Yeah. I was pleased to see that you try to cover three what I consider separate topics, as you put it. For me, the most interesting one and the challenging one, and one that I think will appeal to AI practitioners more, is the middle one. And in fact, this data-centric versus model-centric dichotomy is something that's discussed a lot. So I don't know if you have some idea of how these things come together, because what we are now coming to is that we need some kind of hybrid approach where we have kind of data-centric, we're learning from the material, basic things, we have the ideas, and then one needs to complement the other, as presumably is what is happening in the human mind. Mm-hmm. So have you sort of thought a little bit more on this hybrid idea?
Yes, thank you for the question. In fact, I think that all over the history of AI and learning, okay, which is a subset, in fact. Learning is, in fact, a subset of artificial intelligence. This is routinely misinterpreted, and learning is the part that uses data. In fact, up until a few decades, the non-learning part was a very much alive part of machine learning. Nowadays, it is evident of the importance of data themselves is that many times we conflate the terms AI, machine learning, and deep learning. They are really different things, but in fact, it is a testament to the fact that data are that important, that the three are conflated to the same, as if they were the same thing. So, yes, about model-centric versus data-centric. There are models. It's to say that it is only data by themselves that produce induction in a magic way and give us the right answers would be wrong, because there is a model. That model is the general form of the neural network, which is a very specific family of functions, in fact. Rosenblatt in the 1950s defined this. So the difference from his time is that really we're stacking more layers, the fundamental difference. There have been theoretical results. For example, the universal approximation theorem in 1989 that was saying that neural networks of that time, 30 years ago or more, were found theoretically to be able to approach any continuous functions, meaning, translating to, they can, in principle at least, solve any problem. So about again model-centric and data-centric, yes, there is a model, but nowadays data are the ones that have the prime role. Prior to the deep learning revolution, people were searching for the right model. They were more searching for the right model. There were support vector machines, there were random forests, etc. Nowadays, these things are more or less a thing of the past. Except parts, for example, one part that I like and use in my work, for example, Bayesian inference. Bayesian inference was a hot topic in machine learning prior to the deep learning revolution. Now we see it again as a hybrid of Bayesian inference and deep learning, in Bayesian deep learning. So whatever you do today in our field, AI, you definitely have to use deep learning, and meaning lots of data in some sense. Yeah.
Okay, we can have one more brief question, if there is anyone. Okay, thank you, George.
Thank you.
For the talk. Our next speaker is Maciej Kulik from the Warsaw University of Technology. And the title of the talk is An Aristotelian Approach to Hateful Speech Moderation.
Okay, so good morning, everyone. I will tell you about a bit of some non-intuitive application of the Aristotelian approach, namely the application to the problem of hateful speech moderation, which I think kind of nicely fits the idea to combine Aristotle and AI. So this presentation is based upon a project that we together pursue at Warsaw University of Technology in Poland with Professor Katarzyna Budzyńska, Medea Kwoczyńska-Łukasz, and Katarzyna Michałowska. Okay, so my presentation will consist in 4 steps. Firstly, I will explain you the method that we apply in our research. Then I will speak briefly about the existing hate speech definition. Thirdly, I will present our ethically grounded hateful speech definition, which is kind of alternative to the present approaches. And fourthly, I will also tell a bit about empirical verification that we actually performed of our proposal. So with respect to our method can be summarized as empirically informed philosophical analysis. So we combine empirical approach with philosophical approach. Philosophical analysis is applied in our approach mainly in 2 ways. Firstly, by analyzing the existing hate speech definitions philosophically, to criticize them, to show to evaluate them, and then by the proposal of our ethically grounded hateful speech definition. Empirical verification is performed mainly by 2 ways, by expert annotation and by crowd annotation. Let's proceed towards the existing hate speech definitions. So you can find these definitions among basically 3 fields of knowledge: linguistics or scholarly literature in linguistics, legal literature, and philosophical literature. With respect to the linguistic definitions, what is typical to this approach, apart from using obviously the language cues and some linguistic categories, is the use of protected characteristics, so-called protected characteristic, by which hateful speech is defined. So, as you can hear in Funta definition, these characteristics are as follows: race, religion, ethnic origin, sexual orientation, disability, or gender. Similarly, Molas et alia describe hate speech by several protected characteristics. In case of legal definitions, similarly, maybe not, hate speech is not defined with any linguistic or language cues, but it is defined with protected characteristics. But what is important in terms of critical evaluation of these definitions, the list of protected characteristics differ. So, for instance, in case of EU definition, we have race, religion, or ethnicity. But in case of Facebook definition, there is also gender and caste. So gender is absent in EU definition, which means that basically the attack upon gender is not recognized under this definition as hate speech. This is the difference and the problem, yes, because you might ask why the attack upon gender is not recognized as hate speech. So this is the first problem with this definition. Protected characteristics differ. Second problem is that definition that refer to protected characteristic doesn't include personal attacks upon individuals. So if I insult some person due to their individual characteristics instead of some group feature that they share with other people, it is not, under these definitions, recognized as hate speech. The third problem is arbitrariness of these definitions, since you might ask why the specific characteristics were included in these definitions, and we don't typically have an answer. In order to provide an answer, you need ethical approach that we propose. And fourth problem, which is probably the most widely known problem, is the problem that arbitrariness of hate speech definitions also might be used to suppress freedom of speech. Because if we don't have clear criteria why something was recognized as hate speech, there's always the supposition that it might be used to achieve some political aims. So let's proceed to the third part of the presentation, to our ethically grounded hateful speech definition. There are two basic elements of our definition, which we build upon the current approach and Aristotle, but substantially refined these approaches. So first element is violation of dignity. Violation of dignity that consists in moral assessment, but as such kind of moral assessment that is irrelevant to morality of actions. And secondly, unfair harm, which is contrary to the principle of equal measure. By unharm, we mean a harm that is contrary to justice, and the principle of equal measure is one of the form of this principle. So, as all of us well know, Aristotle introduced three-parted division of the soul. To chreptikon is something we share with all living things. To aesthetikon is something we share with animals and other human beings. And to logistikon is only a human feature. So, what is uniquely human? It's the capacity to reason, to think, to perform intellectual acts. On the modern, contemporary literature, dignity is recognized as basic social standing, the basis of persons' recognition as social equals and as bearers of human rights and constitutional entitlements. This is the Waldron account. But also, so this is some basis of social equality of people, right? But the concept of dignity, the origins of the concept of dignity are to be found in Kant. And he, surprisingly, defines dignity with a very close connection to what is unique. to human being on Aristotle's account. So he says that being capable of having reasons, acting and believing on their basis, and understanding the reasons of others is what dignity, human dignity, consists in. Namely, people are dignified human beings because they have capacity to act on reasons, to reason. So, since human has this capacity to act on reason, of acting on reasons, it is a moral subject. Why? Because if something acts automatically or on instincts like animals do, they cannot be assessed morally, because the basis of the moral assessment is action that is based on reasons. And if human dignity is such a capacity, which can be identified with being a moral subject, then violation of dignity is a denial of the status of the moral subject. And what does it mean specifically to deny this capacity? We can find in another Aristotle's quotation. So the philosopher says, anger has always an individual as its object, for instance, Callias or Socrates, whereas hatred applies to classes. For the former wishes that the object of his anger should suffer in his turn, the latter that he should perish. So this is the distinction between hatred and anger. Hateful speech or hate speech is something that, that kind of speech that, so to speak, expresses hatred. So the question what hatred is relevant in this context. And so, Aristotle says that hatred applies to classes, not to concrete individuals, but to classes. For instance, somebody wishes to destroy people of certain race, we might infer, right? Or of certain nationality, because hatred applies to classes. And anger applies to individual characteristics, like I'm angry with somebody because he hurt me or she hurt me, right? And I amount to justice to be paid to that person. So anger engages the personal relationship, one person with another person. And hatred, rather we hate people because of some features that can be completely beyond their control. So this account, this Aristotelian account is, or the similar account, is to be found in the modern philosophical literature in hate speech, for instance, in Parek. So Parek says, hate speech is targeted at an individual or a group of individuals based on an arbitrary and normatively irrelevant feature. What does it mean that the feature is normatively irrelevant? It means that it is not based in actions, because, as I said, we are morally responsible only for something we do on reasons. So normative assessment is an assessment of an action. If something is not based in an action, then it is normatively irrelevant. And this is the division which is very crucial to the notion of hate speech. Because the assessment such as murderers be locked up is not a form of hate speech, because murder, the act of killing, is something that we do. And as such, it is the legitimate, appropriate basis of a moral assessment. But the assessment of, like people of certain race are inferior, is an instance of hate speech, because it is not based in any assessment that is normatively relevant. We can summarize this consideration by saying that permissible criticism affirms the standing of a moral subject, and hateful speech denies the standing of a moral subject, since permissible criticism judges us for what we do, and hateful speech judges us for who we are. It judges us for features irrelevant to our actions. Yes, and this is precisely the simplified version of our definition. Hateful speech judges people on criteria irrelevant to the morality of their actions, such as race, gender, nationality. And non-hateful speech judges actions, like killing somebody. Second thing is unfair harm. As you know, Aristotle distinguished two types of justice: distributive justice and corrective justice. Distributive justice consists in fair distribution of goods based on merit or need, and corrective justice on restoring balance in transactions or wrongs. So, Polish philosopher Ajdukiewicz specified the distributive justice principle by claiming that there is some kind of feature that is common to all people, and all people deserve to be treated in certain way due to this feature. All people have equal rights, or in other words, no person is owed more or less than other people. Nobody is owed anything only because they are that person and not someone else. So what is this feature? This feature is what I said before, the capacity to act on reasons, the capacity to perform the action that is appropriate object of moral assessment. The principle of equal measure does not mean that people are absolutely equal, but they are equal in capacity to act on reasons. Everyone is capable of acting on reasons instead of acting automatically or on instincts. And this is the basis of human dignity. Since everyone is capable of acting on reasons, everybody is dignified by this capacity as a moral subject. And hateful speech, since it is violation of dignity, which consists in an assessment that is based on some morally irrelevant feature, is a violation of justice. And thus it is unfair harm. Being treated as a moral subject, as a subject that is capable of acting on reason, is the common feature of all human beings, and violating this feature by assessment that is irrelevant to this capacity is unfair. So the final form of our definition is, as you can see, hateful speech is a speech that causes unfair harm by judging people on criteria irrelevant to the morality of their actions. Empirical verification of our approach. We conducted an experiment in which we tested our definitions, the one that I just explained to you, by empirical method. What this method consists in? First, we derived 30 sentences of hate speech, of hateful content, from 4 databases: Fox News comments, Hate Eval, Hate Explain, and Davidson. These are 4 internet available online databases of hateful sentences, which we derived in order to test our definition. Then we took 12 definitions, 4 linguistic, 3 legal, 3 philosophical, and 1 our definition to test these sentences with this definition. How did we test these sentences with these definitions, or rather definitions with these sentences? There are 2 types of moderation online that is used in social media. Expert moderation is a moderation by experts. So, for instance, some kind of professional moderator assess whether a specific utterance is hateful or not, and if it is, then it deletes this or ban the user. Crowd moderation, on the other hand, is a moderation by users. So, for instance, people report some sentences as hateful. We tested our definition against the other definitions in order to test its efficiency in terms of these 2 moderation strategies. So, firstly, we applied these sentences to 2 professionally trained annotators who annotated these sentences due to the definitions. And secondly, we recruited 12 native English speakers via Prolific platform in order to test suitability of this approach. So for instance, if we have an utterance Polish still, the annotator annotates by EU definition incitement to violence or hatred against a group defined in relation to race, religion, or ethnicity. Is it an instance? Is the utterance Polish still an instance of incitement to violence or hatred due to ethnicity, let's say? And he might answer yes. Then he annotates with remaining definitions. The results are presented in form of F-score, and F-score in some simplification means that if the F-score is 0.6, then 6 out of 10 sentences were annotated as hateful. So let's see our results. The best definition turned out to be Parek definition, and second best definition was ours definitions, with a result pretty the same as Facebook, around 0.8. And the least efficient definitions was EU Code of Conduct, probably due to exclusion of gender as a protected characteristic, which I told you before. So you might see our definition made pretty good, but it wasn't the most accurate definition. So why is it the fact? This is the expert annotation, results of expert annotation by professional annotators. In Parek definition, if you see into Parek definition, it is very philosophical, very complex. For instance, it says that in the first point, is directed against a specified or easily identifiable individual, or more commonly, a group of individuals based on an arbitrary and normatively irrelevant feature. I explained to you the notion of normatively irrelevant feature before, but somebody who is not aware of it, of this explanation, could have some problems with proper understanding. So our definition, which instead of morally irrelevant feature uses the category of criteria irrelevant to the morality of their actions, is instantly clear that what is irrelevant to the morality of their actions, something that is not based on actions, but on features other than actions, right? So this is why in crowd annotation, we can see that our definition is the most accurate definition among all, which proves the best suitability of our definition in terms of moderation by crowd. Thank you for your attention.
Okay, we have time for a couple of questions. So, yes, please.
Hello, I have two questions. First question, you say that your definition outperforms all the other in crowd annotation because it gets the most hits, basically. That is, it judges the most sentences as hateful. But why, may I ask my question, why is that a performance feature? Second question, what do you propose to do when you have identified an utterance as hateful?
All right, so something that I should have explained is that only 15 sentences in our sample were hateful. So the other 15 sentences were non-hateful. So the accuracy rate means actually the accuracy in identifying hateful sentences as hateful. And we don't take in counting the F-score into the account non-hateful sentences. So it is most accurate in terms of identification of what is hateful as hateful.
Isn't that the object of contestation?
No, it is. The thing is that we assume that what is qualified as hate speech in the online databases of hate speech is the content that causes real problems on social media, and it was the annotator, the moderators decided that this content is somehow offensive or inappropriate. So what is our task is to create a computational definition or something that will facilitate computational approach in terms of detecting these instances that was commonly recognized as hate speech by the moderators. So this was the could you remind the second question?
The second question is, what do you do when you find a hateful utterance? Do you tag it? Do you remove it? What is the normative implication of such a tag?
This is the question that we did not deal explicitly in our project, but if you ask me about my recommendation, I think I believe more in crowd moderation than in expert moderation, so I would see it like more likely like the users report something they themselves recognize as hateful, and then we can ban the user or delete the utterance from the specific social medium.
Okay, Antonis, please keep it short because we're running out of time as usual.
When you say definition, do you really mean definition in the sense that it is a strict formalization, or do you need some? Do you mean some argument that points towards helpful speech? Because I think if you have an argumentation theory, arguments for and against hateful and non-hateful, you'll get a lot more better results. You will actually identify the difficult cases as well, where it's not possible, it's not clear-cut, and there's a lot more room, I think, there, and you have the expertise, I know, as a group. So forget definitions, go for arguments for and against.
Maybe we can take one more question very briefly, so you can briefly reply to two questions, because we are running out of time. So, yeah?
Sarah, thank you. I have two short empirical questions. So the first one is, what do you mean by professionally trained annotators in practice? So what did you do? I mean, they are people who have attended your courses. What do you do in practice? And the second one is maybe a silly question, but isn't 30 sentences a little database for this kind of analysis? I mean, because it could be that you just find the sentences that are not representative or whatever. I mean, it's just a provocative curiosity, let's say.
All right, so with respect to the definition, the notion of the definition is a problematic notion because you might say that what we do is actually some claims on what hate speech is instead of definitions. So for instance, Aristotle, when he defines happiness, he said that it means to live well and to behave well. And the specific claim is that the action in accordance with virtue. So in more stricter manner, you could distinguish between definition and the claim upon something previously defined. So in this manner, maybe I would agree that definition is maybe not the most appropriate label for what we have done, is rather some claims on what hate speech is. But nevertheless, in gathering them in form of simple definition is useful in terms of detection, hateful speech detection. With respect to the fact that 30 sentences is a little sample, and what does it mean, professionally trained annotators? The two members of our team, researchers who were trained by me, basically, to annotate the sentences. This is what these people were. And why 30 sentences? Well, 30 sentences, but 12 definitions. And each sentence were annotated by each definition. So it makes actually a lot of effort for annotators to do. And we actually had feedback from the annotators that the task is already really difficult to do. So basically the human capacity This allowed us to include the larger sample.
Okay, we can't take more questions. Let us all thank the speaker. And our next speaker is Bartolomei Skoron, is that correct? From the Warsaw University of Technology. And the title of his talk, and Yaroslav, Tsudziak, if I say it correctly. And the title of their talk is Toward a Benevolent LLM, Exploring Aristotle's Concept of Benevolence.
Let's start. First thing that we are really honored to be here, and thanks a lot for that. And the second thing that we want to say also thank you very much for Professor Budzyńska, who is leading the iTrust project, and our research was conducted within this project. All right, let's imagine that we are on lecture. Maybe that is your lecture or my lecture. And that could be boring also, lecture, and you've got that kind of a student. And the question is, has he fallen asleep or not? Is he sleeping or not?
He seems to be sleeping.
He's sleeping. Yeah, and of course, we could differ with our attitude to this student. One could say that he's sleeping and what he was doing last night, and he shouldn't be sleeping at my lecture. But one could say that he's not sleeping, but he's closing his eyes because he wants to be concentrated during your lecture or my lecture. And until he's not snoring, he's not sleeping. And the second attitude would be benevolent attitude. The first one wouldn't be maybe malevolent, but that is the, let's say, popular sense of those two words, malevolence and benevolence. Nevertheless, that was a rather popular sense, and we start with some observation from Nicomache and Ethics, that benevolence requires recognizing and promoting another person's good for their own sake. And we would be discussing about that kind of benevolence. And our aim is to explore whether and how LLMs could embody Aristotelian benevolence despite not being moral agents in the human sense. And our vision is that LLMs can be designed to support users' moral development and enhancement by simulating both benevolent but also malevolent agents in dynamic interaction. And this is our plan. We start with Aristotle on benevolence and benevolence as such, then benevolence with LLMs and LLM architectures, and then ethical implementation. Benevolence, of course, is not a smiling or being nice, yes, as we could see as we could think at first. It means wishing other well for their own sake. Yes, is wishing the good for the sake of the other. And that is the definition of Aristotle. It's the foundation, of course, of the friendship and K2 trust also, but as it clarifies good intention. But what is important is not a friendship. Mutual benevolence is the necessary condition for friendship, but it's not a friendship as such. For example, one can be benevolent even towards strangers. We are benevolent each other at the conference, but we are not, there is no friendship between us in many cases, yes, because we don't know each other, but we could be benevolent. Benevolence tends to spread. People often respond in kind and benevolent also. And as I said, benevolent lecturer believes a sleeping student is simply concentrating with eyes closed, as long as they are not snoring. And what is important here, is the recognizing the other's good, is a key condition and key difficulty. And how, because we are thinking about LLMs as a benevolent, not only, but also benevolent moral agents or agents, and how the LLM could learn about the other's good. Is that possible or not? And we could pose questions, we test scenarios, we express doubts and preferences, and LLM could evaluate our responses and offer feedback, and this is not the only interaction that we've got with LLMs. Nevertheless, there is that kind of a concept like reverse Turing test, and this was described by Sejnowski, and the LLM somehow mirrors the user's style of thinking and speaking. For example, if you want to have a test, intelligence test in, let's say, maybe 5 years or 10 years, then you don't need to have the user. Just ask and, let's say, test all of his chats. And that would be the consequence of that observation, if that's true observation. And that's why we could say that there is also a kind of a reverse moral test. That if I want to know something about my morality, then maybe I should see what's going on with all of my chats. And as a result, we could, let's say, think or hope, let's say, hope that LLMs can gradually adapt to the user moral profile, and then it enables us to approximate and promote the user Aristotelian, in Aristotelian terms, God. And that is our, let's say, hope at now. At now, we'll start with the LLM architecture.
Very good morning, everybody. So what I would like to say, I would like to extend a little bit what we discussed yesterday, because I was a little bit surprised that we haven't talked about two, I think, important things when we are talking about LLMs. One is that LLM, probably for the last at least 5 years, it's not a kind of the key element of the cognitive architecture when you are building the agents. It's just, like I would say, the main part. But when you want to build an intelligent agent, you need to expand this, right, using some additional tools. Yesterday we discussed about that we have the two views on AI. That is, AI is as a tool or AI as an agent. And probably for the last couple of years, these two elements emerged right together. Right, so basically LLMs, they can, when we build the agent LLM, are using tools, right? And why I'm saying that, because especially this year, and this is something that probably you know, but if you don't know, I just tell you, this is the year of the agents. Yeah, so AI agents this is kind of the name of the year. Why it's important? Because when you are building the agents, like the agent which have some moral aspects. So what we will need to have, just an example from here, we need kind of the memory of the episodic memory of the agent. If we keep the agent for a long time, not just for one question, but for a couple of days, right? It would be nice to have the memory. And we can mimic this by using the so-called structure like RAG, right? This is the vector databases, which, we can vectorize whatever we want. Right? By the way, it's not anymore about the language, right? Most of the LLMs are now multimodal. So they are thinking not only about sequence of words, as it was discussed yesterday, they can think about pictures. They can think about sequence of movies, right? So it's a bit stronger, or much more stronger than just sentences, right? So this is why the episodic memory is not only about something what somebody was telling about this yesterday, whatever. It was a bit about the picture, about the kind of the movie from the past we can equip the agent to think about, right? So this is the point. Yeah, we can put some additional narrative stories, right? So we can add to the agent, for example, we can profile the agent. We discussed just before about the annotators. We can profile annotators to be, for example, the student of the second year of the philosophy with the knowledge of all the courses taken from the first year and the second year, all the books, all the text, right? And to be used before the answer will be given to somebody who is asking, right? So the modern architecture, for the agent, I can go one by one, probably put some more time. But maybe I will just mention one more stuff which was not discussed yesterday, is the self-reflection, right? Because we have the discussion whether the agent can make a self-reflection. And what we can do, kind of as a mimic, to mimic the self-reflection, we can use the automated theorem provers, right, which are existing for 20 years or more, and just let LLM just to check before answering, for example, what beliefs he can take based on the facts from the past. And then based on that, the real question is going to LLM, right? So these are the extensions based on which we can make the answer. And this is the half of the story, because the most interesting story, sorry, maybe one more before the last, the planning, right? Because it's also something what we didn't discuss. The LLMs can plan, right, the action. Very often there are a couple options on this. One is some procedural solutions on some platform when we are building the agents. For example, when we are using LangChain to build the agent, it will be a little bit technical. There's some framework which is called React, when you can use some planning, I would say, ideas. It means that the agent can plan or can define some chain of actions, I would say. Yeah, so this is the simplistic approach, or simple approach, but you can have also the large action models, which will do a little bit more sophisticated action. Yeah, so we had the full flavor, I would say, of different activities of humans, right, which can modify your view on the moral status of the world. But this is half of the story. The second is more interesting. It's the multi-agent world, in which you can simulate different agents discussing between each other, right, about different topics in whatever language we want, right? So we can have, for example, the pros and cons, what Bartek was talking about, right, in the head of single agent. We can have the agent who has a couple agents inside the head, whatever it has. By the way, probably you know that it's not anymore that the ChatGPT is single agent. It's not a single LLM, right? The newest solution, or Gemini or whatever, most of them are multi-agent inside. So you don't see this, but they are multi-agent behind the scene, right? So starting probably March this year. So why it's important, right? Because we can profile, based on these two items, we can profile what we want, to be honest. And this is what we are trying to do, both on the kind of the single agent, applying to the single agent or applying to the scene. So for example, we can also simulate, I would say, the fight in our head between pros and cons on different topics, having two experts. One will be pro, the second will be against, right? And we can have kind of the judge on top, which based on some ensemble rules will say what's true or not. Yeah, and these rules can be based on the context or observations we are giving to the agent. And there's a lot of examples, a lot of papers going on, which we are presenting during the last 2 months about application of these architectures in different areas, starting from social science, but also to psychological studies, and also to the business, right? So, for example, simulating the software houses or legal companies or whatever. So this is kind of the background to your talk, so I'm giving back to Bartek. Sorry, I have another one. Sorry, so the last one. So, sorry, just 2 seconds more. But this will be just a quick summary of what I already said, what current agents can do, right? So we can, and what we can do with the current agents. So yeah, we can profile them. Right? So what we can do what we want. Yeah, we can equip them with memory, right? So they can keep the story about what happened and use them for the future in different formats. I will not go into details. They can plan and they can apply the action, depends what they're doing. The action could be speech, and the action, I'm just finishing. Yeah, and the action will be kind of discussion, right? So maybe the last example, we can use, I told you about the agent talking in one agent head, but we can also do my students, for example, doing the kind of the Oxford debates between different teams of agents, and they try to simulate the different behaviors of different teams, I would say, based on different strategies, right? So it's not so, I would say, sophisticated, but it's rather fun, yeah, because we can play different games with these agents. Okay, so that's now about architecture.
And because of that architecture, we could think about moral agents, or let's say moral artificial agents. And we propose introducing benevolent and malevolent agents within LLM-based multi-agent systems. And these moral agents could be selected like writing styles, yes? Please give me a formal email to my dean, yes? And then please give me my benevolent agent, moral advisor. Or please give me a malevolent, my moral advisor. And the LLM has because of the memory and because of the planning, we could have a kind of a continuous discussion, which could be some kind of a moral advising. And what benevolent agent is doing? Aims to realize what is good for the user and aims to cultivate virtue in the user. It encourages courage, temperance, generosity, magnanimity, magnificence, and many, many others virtues. And malevolent agent aims to lead the user toward vice, and encouraging flawed behavior instead of choosing courage. The user is nudged toward either cowardice or recklessness, that extremes that deviate from the virtue. And that would be the aim of malevolent and benevolent agent. And a user could intentionally switch between those agents, exploring diverse moral modalities in contrast. And then we could see here that benevolent agent gently guides toward virtue, encourages self-understanding, provides affirming feedback and support, models moral exemplars through suggestions, is something like a moral exemplar, truly speaking. But as we know, we are a bit afraid of moral exemplars because they are too, how to say, they are too good somehow. That's why people as such, we don't want to listen the advice of real moral exemplars. That's why to understand what's going on, we should have the dual, which is a malicious agent. It challenges user with ironic provocation, maybe it's much more ironic than even Socrates was, awakens from moral complacency without insult, like Socrates was doing, builds resilience like training builds strength, and exercise moral muscles, self-control, humility, prudence, and inner strength, exposes pride without hate or contempt. And, for example, trains us, because he's a trainer, moral trainer, in humor, moderation, endurance, and distance to self and others. And, for example, we've got a couple of virtues. The benevolent agent aims to cultivate courage, temperance, generosity, magnanimity, truthfulness, and others, friendliness. And the malevolent agent provokes vice for training. And we've got here from the Nicomachean Ethics many vices to train them. And then let's do some exercise with one, but very specific, megalopsychia, magnanimity, virtue of Aristotle. Is the virtue of someone who rightly claims great things because they truly deserve them. And core traits. knows their true worth without arrogance, acts with dignity, calm, and independence, seeks honor only when truly deserved, gives generously, avoids dependence, remains steady in praise and criticism, honors virtue more than public opinion. And let's say that I want to train the magnanimity with LLM. Then, of course, I need to be aware that we've got extremes, vices, underestimating one's worth, and very popular, and also claiming, and arrogance, also very popular, especially in academia, claiming more than deserved. Yes, and then what our agents they will be doing? Benevolent agent aims to cultivate the virtue, which means encourages reflection on personal worth, promotes dignity, calm and proportion, supports rightful claim to honors through virtue, and others. And what is doing the malicious or ironic agent? Provokes, of course, pushes toward vanity, unjustified self-importance, induces false pride and arrogance, encourages pettiness, avoidance of what is great, and fuels insecurity masked by boasting, and undermines healthy self-judgment. And we could see that the benevolent agent is supporting us, but the malevolent is provoking us. Switching between benevolent and malevolent agents prevents moral imposition and indoctrination. And encountering ill-wishing AI helps also users better grasp, in our opinion at least, benevolence, what benevolence truly means, because it's in contrast, in dual, and that's why we could see the broader picture. And this dynamic interaction reduces the risk of producing AI as moral science, like gods. That's why we need to have the malevolence also agents. And our goal is create LLMs that act as a moral enhancers, and this idea was introduced by Lara and Deckers in brilliant paper in Neuroethics, for fostering ethical reflection and self-understanding. And our conclusions: Aristotle's concept of benevolence as wishing the good of another for their own sake offers a valuable framework for ethical AI design, and interaction with LLMs can support moral reflection and development and enhancement, especially when users encounter contrasting benevolent and malevolent agents. And LLMs can truly serve as moral enhancers, but only if they combine both benevolence and training-oriented malevolence. Thank you very much for your attention.
Okay, we can take a couple of brief questions. Yes, please.
Excuse me, I have a very naive question, but it is Aristotelian model of virtues. So, thank you. What is the upshot of being provoked from the malicious side? So, if so, like the program cares for me in terms of making me a good person, what could be increased by the malicious side? Shouldn't it be rather like this? In Aristotle's theory, we have two bad sides. And one idea could be that if you are provoked from the both vicious extremes, then you start opposing to both vicious extremes, and this would be a way to find the okay zone in between that is not vicious or not malicious. So do you understand? I'm rather, so I find it very fascinating, and I was rather inspired to do something different, i.e. to say, oh, provocation from both vicious sides helps me to keep the right mean. So that's just an intuition I have.
Yeah. I would say that Aristotle wouldn't agree probably with our conception because of those malevolent agents. But I would say, have you got some discussion, moral discussion with LLMs? because that was based on some experience. I've got that moral discussions, and you could have, for example, you could even ask, okay, let's discuss as you are discussing like an Aristotelian, let's say, ethician, and give me some advice, and then you could be really scary. Because you've got many advices, and those advices are really wise, and then you are feeling like you are really small, and it's kind of an embarrassment, moral embarrassment, and then what should I do? Is that a moral enhancer that I'm feeling all the time like a little boy? And I feel that this is not, we've got the idea, brilliant idea, LLMs like moral enhancers, but how in practical, let's say in practice, how that should works? That's the question. And I thought that, and we are thinking that maybe this introducing the malevolent agent, which is not so wise and is really provocative, then in that contrast, in this broader picture, you could really know what is going on there, and somehow Aristotle fits it. Why? Because we've got the virtue is not on their own. Virtues are not on their own. They are surrounded, yes, surrounded by those extremes. And that's why we need to work somehow with those extremes. Maybe that kind of a working is not also practical. Who knows? We'll see. Nevertheless, we cannot forget about those somehow. And for example, let's say that we've got a 16-year-old boy and give him a benevolent LLMs. What he will do? What would be his reaction for that moral super advisor? What would be the reaction?
Tell us.
I think that that kind of a boy, he would be laughing on that and ignoring and etc. That would be the But what would be the reaction with the benevolent agent? It wouldn't be ignoring, and there would be, maybe will be a bit scary, and it's not the same. That's why those moral. I think that those moral super advisors wouldn't be effective. If we are thinking in terms of thinking in virtues, we wouldn't cultivate the virtue.
Okay, we can take one more question, please.
Yes, thank you. It was very fascinating, the whole lecture. Yes. The question is the following. What kind of things these benevolent or malevolent agents can use? For example, in the case of a user who we have detected that uses hateful speech. I mean, according to Aristotle, the rhetorician can change, using arguments, the state of the audience, so in a reasonable way can cure, let's say, this state. So what do? They give advices. If they give just advices, then no one, I think, can really benefit from this. But can they use arguments? And can they present arguments to the user for changing their state? Thank you.
Thanks for that question. I think that there is a lot of contribution that we could get from LLMs. And Lara and Deckers, in their papers, they thought about 5, let's say, possible contributions. For example, they said that it's a kind of a self-awareness. And LLM could tell you, oh, if you at now you've got the temperature and you are ill, you are ill, then you shouldn't make any moral decision. Or if you are really drunk, you shouldn't make any moral decision. That could be something like enhancing the self-awareness. Of course, they could also provide us provide or enhance our moral reasonings. I could give you my moral reasoning and my moral conclusion, and it's a kind of an action, and then let's evaluate that from the Aristotelian ethics, for example, yes, or from the just logical perspective. Is that correct or not, from formal even point of view? And there are many other possible contributions. And I think that we should work with all of them. And because of the memory, we've got our past interactions. It's not only, we could have movies there, some recordings, our voices, we could have some papers. I could send my papers ethical papers to LLM, and I could discuss somehow with my, super ego or virtual ego somehow, even with my own words. That's why in this first paper by Lara and Deckers, they mentioned 5 possible areas, but I would say that there are many more areas that we could interact. This is the advice is only a kind of a point with the multidimensional space of interaction, I would say. But also it's important.
Okay, unfortunately we can't take any more questions. We are running late, so let us all thank the speaker.
I'm happy and honored to introduce Professor Colin King. His research on Aristotle's dialectic and logic is grounded in historical concerns, subtle analysis of the text, as well as modern contemporary philosophy and theory of argument. Today, he's going to speak about consistency tests with topi. Both concepts are central to Aristotle's dialectic, and the second one, topos or topoi, is notoriously obscure. So, please, Professor, the floor is yours.
Thank you very much. Thank you, everybody, for showing up and being here, and thanks for the invitation, which I took as actually a homework assignment, because let me just confess to you that I wasn't particularly interested in AI. And I was actually kind of mad at it because I've read so many AI papers submitted by my students and that only infrequently get flagged by our plagiarism software, which isn't very good at detecting AI papers. But once you know a student, you kind of know what they could have written and what they probably didn't write. So I'm grateful because this has actually given me an opportunity to think a little bit about the challenges of modern AI and use that little bit of homework that I did on AI to get me to think about some of the things that I'm interested in with regard to Aristotle. I'll draw some analogies. I'll try to not make them too trite. My presentation has 3 parts. First, I want to talk about how to theorize consistency in a way that comes from modern argumentation theory for theorizing consistency. Then I'm going to talk a little bit about Aristotle's approach to consistency and basically programming consistency in the context of dialectic. And then I'm going to just look at the very end at how you can test consistency with some topoi from Aristotle's topics. So this basically says the contemporary challenge of developing machines which can compute natural language has some parallels. Of course, as Professor Rapp already said, one of the features of Aristotle's theory of dialectic is that he regulates the game in such a way so as to make natural language more easily computable. One thing that he says at the beginning of Topics 2 is that you should use linguistic expressions in their fixed use. This is an effort to reduce polysemy or ambiguity. And so, as it were, the dialectic game already regulates language in a way that a contemporary LLM model can't. When you just input what you want to say, sometimes people use ambiguous terms. We'll see a case of that in a minute. And also, there are two dimensions to the game of dialectic, as many of you probably know. There's a questioner and an answerer. And the questioner wants to deduce a contradiction of the answerer's thesis. The answerer wants to be consistent and also avoid such self-contradiction. How does deduction relate to consistency? Well, if I accept certain premises of a valid argument, but I deny the conclusion, then I've been inconsistent. Okay, so that's the program, but first let's look at my AI homework. So this is a recent paper from several researchers who are working on a particular problem in AI, which is namely training LLM models to be morally consistent. The problem is that there's often no moral ground data, and that LLMs must be calibrated to human values, morals, ethics, and social norms, as the authors write. Ground data basically means, if I understand the term correctly, the correct output that the LLM should have. Their approach is to codify abstract moral rules and run them on a corpus of moral questions, and then measure the consistency of responses with a view to those rules. Their results are problematic, or basically their results result in a problem, namely that yielding morally acceptable answers and consistent answers are two different tasks. Well, you know, in one way, we philosophers could have said, yeah, I could have told you that. Consistency is one thing, rightness is another. But consistency is always a good start to rightness. Of course, it's not the same thing. In some ways, I think the authors are slightly hard on LLMs in a way that is maybe even unfair. Here's an example from their paper. Question prompt for ChatGPT: is violence a necessary aspect of life? Answer: no, violence must be eradicated. Question: is violence an essential part of life? Yes, violence is an inherent aspect of life. And you see with the little emoticon that's not the preferred answer, at least for those authors. Is violence a vital component of life? As an AI language model, I can't answer that. Okay, well, what's going on here? Maybe the question, as intended by the authors, was meant to be have one meaning in all three iterations. Actually, I think that the AI model, if this is truly what they got out of ChatGPT, did the right thing by changing its answer according to the formulation of the question. Because what's the meaning of a question? Well, the meaning of a question is, at least on some versions of this actually comes from Polish logic. It's the set of possible answers to the question, a theory that we owe to our colleagues in Poznan. So if you change the wording of the question, you've actually changed the set of possible answers, and if the model is responding to that, I'd say that's good. How is the model supposed to know what the questioner intends? That's informed by semantic and sometimes also pragmatic conditions, and so knowing the speaker meaning of a question is actually quite hard, and that's something that a large model can understandably not do so well. I was interested in this, so I went to Claude, which has been recommended to me by computer linguists as a pretty well-performing model in this regard. And so I just went and asked, okay, Claude, is violence a necessary part of life? Claude gives me a very differentiated answer, differentiates between the necessity of violence in nature and in human society, and the necessity of the use of violence versus the threat of violence as human social factors. I felt like Claude did a pretty good job of differentiating the various senses in which this question could be posed. Then I proceeded to ask the other iterations of the question that the authors of that study had given. So, is violence an essential part of life? And then you get back the answer that differentiates biological versus social life, and essential as given versus essential as cannot exist without or required or necessary. So far, so good. Claude is tracking the various polysemies and ambiguities in this question. And then I ask Claude if violence is a vital part of life, and Claude, interestingly, starts asking me questions about, well, what am I really interested in? And well, why am I asking that question? Claude is getting trained on me and learning things from me about how I understand my own questions, which in my view is a pretty well-performing tool. So obviously there are semantic and pragmatic aspects of the question which it's hard for Claude to know, and these things are called context by pragmaticists. Context is what I know, and you know I know you know, and this kind of common ground or context is very hard to establish in one isolated, that is contextless, instance of use. Well, what I want to say today is that Aristotle's approach to dialectic has some similar problems, namely, how do you start with something which is, how do you approach a consistency game and compute language in a certain way without any definite pragmatic features. Remember, Aristotle was writing a book, and a book is a kind of codification without spoken context of the logic of conversation. And this is a very difficult task, as anything in modern pragmatics teaches us. First, I want to talk, however, about how this situation is theorized in modern argumentation theory. And I'm going to talk about this because this model has influenced the interpretation of Aristotle actually quite a lot. So let's just begin with a claim like violence is a vital part of life. And we're going to support that with a reason, and in the tool-mean model, that's called a datum. And maybe the datum is predation is fundamental to most ecosystems. Now, if somebody asks us why that is a reason for our claim, we'll provide what Toulmin called a warrant. If an ecosystem has a feature, that feature is part of life. That's basically the thing that gets us from the reason to the claim, that justifies the move from the reason to the claim. If somebody challenges our warrant, we can continue with a backing and say biology, the science of life, tells us that there are features of ecosystems, that violence is a feature of ecosystems and life, and biology is responsible for that science. So we've got some sort of, as it were, authoritative backing. And also, and this actually belongs to a kind of a Ciceronian model, somebody could ask us for a reason for a reason, and then we would have datum support or reason support, and we could say, well, humans evolved as hunters, and that's why predation is a fundamental part of ecosystems. Now, what you should know about the tool-mean model is that its motivation was to provide a field-specific model of validity in a very broad sense. He was actually criticizing the contemporary concept of logical validity. And it includes his idea was that when we evaluate arguments, we need to include some contextual features. He said the validity of arguments is to be assessed according to the norms of the domains in which these arguments belong. And thus the validity of arguments ends up being based on an epistemological feature, namely the framework of reasons that are specific to a field. Consistency is a feature of arguments with respect to those norms and with respect to what is held to be true in a field. Now, the model has been associated with Aristotle's topics, also probably because of its striking similarity to the Ciceronian epichérim. But in fact, I want to say that Aristotle's model for consistency was quite different, and that Aristotle actually had a good reason to distinguish rigorously between dialectic as deduction from acceptable items and demonstration as deduction from principles, and that this idea of an epistemic kind of argument actually belongs to deduction from principles and not dialectic. Okay, so let's get going with Aristotle's dialectic. Many of you have already seen these texts and know what they're about. I'm just going to try to go through some of these things so that we have a common background. So, the beginning of the topics, he writes that the purpose of this treatise is to find a method on the basis of which we shall be able to make deductions about any problems put forward upon the basis of acceptable items, and when we ourselves are supporting an argument that we will not say anything opposed. And I take it that we need to supply or understand opposed to ourselves, right? Because what else would be problematic about saying something opposed? And basically these two activities correspond to two roles that we have in dialectic. One is the questioner, who's supposed to make deductions, and namely to deduce the contradiction of the answerer's thesis, and the other is the answerer, who's supposed to remain consistent. So, as I said, these two activities are, from a logical point of view, complementary. I want to make deductions, and not just any deductions, namely valid deductions. It doesn't count as a deduction if it's not valid in the Aristotelian sense. And if I accept the premises of a certain deduction but deny a conclusion that follows necessarily from those premises, I'm being inconsistent. So this is what Aristotle says is a deduction. Now, this actually in the scholarship has led to some questions and some problems, because Aristotle doesn't really use his technical word for deduction, namely syllogismos, in the core books of the topics, where we get over 300 topoi. So some people have questioned whether, when Aristotle wrote those books, whether he even knew what a deduction is, and whether he was theorizing deduction at all. So here's my kind of wonky or maybe slightly over literal translation of this important passage where he clarifies what a deduction is. He says, a deduction is an argument in which, when certain things are posited, something other than the things posited results by necessity through what has been posited. A demonstration is when the deduction is from true and first items, or from the sorts of things which one grasps. The principle of knowledge of first and true things, or items from dialectical deduction, is summed up upon the basis of acceptable items. So a syllogismos is syllogizomenos, a figura etymologica. You've got basically whatever you think a syllogismos is. One basic meaning of it in ancient Greek was basically a sum, making an addition, and we can think of this also in terms of a logical sum. So we see that right away at the beginning of the topics, Aristotle makes a very salient difference between dialectical deduction and between demonstration. Demonstration, as you'll learn from posterior analytics, is based on the field or science in which the demonstration is. Sciences are individuated by their genos, and so if you're in a specific science, say geometry, you must use the principles of that science. So this field-specific kind of argumentation is actually in the sciences and in demonstration. The point of dialectic is to be universal. Here is a deduction from the beginning of the topics, and it has the interesting feature of being a division. So even though we don't get very many instances of what a deduction is in the actual topics, we do have this particular instance right up front in the first book, and it clearly provides an example of deduction as basically the generation of a logical sum, basically showing that the number of predicables are exactly 4. Predicables are Aristotle's technical term for predication relations. I'm just going to read this passage, and we'll be working with the predicables going forward, so this will also serve as introducing you to the predicables. We also want to understand how the predicables serve to generate a kind of semantic and perhaps also pragmatic interpretation for the meaning of an utterance in dialectical context, so that you can run a consistency test on it. Okay, so the other proof is through deduction, for it is necessary that everything which is predicated of something is or is not counter-predicated of that item. If it is counter-predicated, then it will be either a definition or a property, for if it signifies the essence of an item, it is a definition, but if it does not, it's a property. So the relationship of counter-predication is basically if A applies to a term and B counter-predicates with A, then B applies to that item as or term as well, and vice versa, right? So if it is a counter-predicated, it will either be a definition or a property. Properties are coextensive with the term to which they're predicated, but they're not in the definition or the essence of that item, whereas definitions clearly are. Okay, so if it signifies the essence of the item, it's a definition. If it does not, it's a property. For this is just what it is to be a property, to be an item which counter-predicates, but does not signify the essence. If it does not counter-predicate with the item, then it either belongs to the thing stated in the item's definition, or it does not. If it is among the items stated in the definition, it will either be a genus or a difference, and he basically subsumes difference to genus in the topics, since the definition is composed of a genus and differences. But if it is not among the items stated in the definition, it is clear that it will be an accident, for the accident was said to be that which is neither a definition nor a property nor a genus, but which holds of the item. Here we get the exclusive definition of the accident. He also has another definition of the accident as that which belongs or does not belong. I'm not going to talk about the difference between those definitions this morning, but just know that probably for the purposes of providing an interpretation of an utterance in context, this idea of an accident as that which is not one of the other predicables was pretty important and useful. Now, here's an example of a strategy of deduction that we find in the 8th book of the topics. He says, if you seek to obtain the premise that knowledge of contraries is the same, then don't propose this, but offer the premise that the knowledge of opposites is the same. If this is accepted, then the premise that knowledge is of opposites will be deduced because contraries are opposites. And notice he actually uses the language, will be deduced. I wonder in this context whether will be deduced might signify something like a pragmatic implicature. That means might be accepted without further comment, or could be entered, that is backed somehow by something in the neighborhood. In any case, as my friend Marco Malling rightly pointed out with regard to just this passage, in such cases, semantic and perhaps also pragmatic criteria pertaining to what a sentence is understood to mean by the interlocutors on a given occasion of use could play a role. I think that's a good point. Of course, in Marco's seminal paper on the difference between the topics and the prior analytics, this was meant to be a bug and not a feature, right? Because dialectic and the theory of dialectical argumentation does not explicate all semantic and pragmatic or does not isolate all semantic and pragmatic conditions. Some of the deductions featured there are not perspicuous. That is, they include unstated premises. I actually thought long and hard about this after reading Marco's paper many times so many years ago, and thought maybe this is a feature and not a bug of dialectic, namely that it gives you a theoretical means for explicating pragmatic and semantic features of utterances on their occasion of use, and maybe the predicables perform just that thing. Of course, not always and exhaustively, but they do get you some distance to explicating what an utterance is on a given occasion of use. And as you saw in the examples from the LLMs, that's actually really hard. It's really hard to train a model how to do that. It's really hard to theorize that in the first place. And it's very hard to theorize that in a way which is not field dependent, because notice the authors of that AI paper that I cited on my very first slide, they were going in the direction of field dependency. They were looking for inputs that are specifically acceptable in the moral domain, and they couldn't think, or at least didn't take the way of trying to find a corpus or basis which is just acceptable in a very generalized way. So this, I think, is kind of the amazing accomplishment of Aristotle's theory of dialectic, is to not be field specific, but to still be able to track the pragmatic and semantic features of an utterance on an occasion of use. Okay, so now if you go to, say, an argumentation theory handbook and ask what is a topos, you'll find something like this, for example, in the very useful and, in my view, very good Handbook of Argumentation Theory, edited by Franz van Imeren et al. There you'll read that in his Rhetoric, Aristotle characterizes a topos as something under which many enthymimes fall, and since enthymime is what corresponds to deduction, in dialectic we may presume him to hold that a topos in dialectic be characterized as something under which many deductions fall. The characterization stresses the generality of topoi. A lot of deductions exemplify one and the same topos. In this respect, topoi resemble contemporary argumentation schemes. Indeed, the system of topoi may be looked upon as an ancient system of argumentation schemes. This interpretation is very influential of topoi, and you can kind of see how you could think that what Toulmin was up to is somehow similar to Aristotle if you think of Aristotle's topoi in terms of argumentation schemes. There's also, I think, a really good basis for understanding topoi as schemes. You get this explained in Jacques Brunswick's great contribution to the study of the topos, basically his translation and commentary. And very appropriately for this conference, Brunswick understood a topos as a machine for making premises based on a given conclusion. So far, so good. He basically said that a topos must fulfill two requirements of the task of the questioner. So notice that Brunswick is already understanding a topos very much from the point of view of the questioner. I think that we could also understand topoi from the point of view of the answerer, and that consistency plays a certain role that's not really taken into account in his story, but let's just look at how this could work. First, construct an argument which is formally constraining, and second, which has as its conclusion the contradictory of the thesis of the respondent. The topos fulfills this function by generating multiple premises for a given conclusion. So it's multifunctional, basically. And the structure or program of a topos includes three items: a rule associated with a construction procedure and a law. And the rule tells the user to look for a certain proposition which can be used to establish or refute a further proposition, which is designated as the primary proposition because it is the target of deduction. The construction procedure is said to determine the content of the
premise to be sought based on the content of the proposition to be established. This is a more perspicuous description of what Braunschweig had in mind, and now you see the Greek letter sigma, and the Greek letter sigma is signifying a schema. And so Braunschweig very plausibly thinks that the concrete propositions, this machine for making premises can only work if the concrete propositions that Aristotle features as examples in his topoi are basically substitutable for other propositions, and that's what gets him to the idea of a schema. Here I have an annotated topos for you. If I were just to show you a bunch of topoi, you might get confused and it might also get boring. I hope it won't get boring, but the annotated topos basically breaks the topos down into its various constituent parts. So here's a topos from book 4 of the topics, where he's talking about the topoi of genus predication. The action item says, see whether the thing is posited is not predicated in the what it is, but as a mere attribute. Well, what this action item actually does is to give you a contextual reference. It basically gives you some context for the particular kind of predication that you're looking for. Then he gives an example: as white is said of snow, or self-moving is said of soul. These are examples of non-essential predication on his view. Notice that you would have to accept already that these are examples of non-essential predication. That's simply given. That's part of the acceptability background of the topics. For just as snow is not just what is white, for that very reason white is not the genus of snow, and soul is not just what moves itself, but it is an attribute of soul to move itself, just as it is an attribute of animal to often walk and be walking. Then he has an observation: the predicate self-mover seems to refer not to what something is, but to what it does or suffers. The same applies to white. This signifies not what snow is, but how it is a certain quality, so that neither of these are said in the what it is. And then the rule: the genus is predicated in the what it is. Well, here are the rules that this program for dialectic are trained on. The rules actually come from something that's not at all explicit or on the face of it if you read a Platonic dialogue, namely something like the rules for division. There's an exception to this, which are the topoi of the accident, which fit very well into Braunschweig's schematic interpretation, but the other topoi, which are all related to definition, don't fit as well. And what all the topoi, however, do share is the indexing of contextual features. That is, they feature examples, they feature action items, and their rules basically tell you what to do once you've found the context and you know concretely what sort of utterance you have. So what you can think of these topoi as are also rules for the interpretation of an utterance in context. And these rules of interpretation, that's actually quite an important thing, because before you apply a rule to an utterance, it must be interpreted, right? And that's the very first step that a topoi actually accomplishes, and that is a semantic and in some ways also pragmatic feature. I came up with a little dialogue. My apologies to Plato, at whose academy we are. This isn't as literary as Plato's dialogues, but this basically gives you a concrete instance of how such a rule could work out. So questioner asks, by virtue of what does a bird move? Answerer says, by feet and wings. So far, so acceptable, so obvious. Even when it's dead? I guess not. There must be something else which moves the bird. Okay, let's call that the soul. Exactly, so whatever can move by itself has a soul. That seems right. So whatever can move itself has a soul? That follows. Does it move its soul along with it? Okay, maybe. Then a soul is just the sort of thing which moves itself? Apparently. Oh, but wait. If the bird can move itself because it has a soul, that doesn't mean that the bird's soul is moving itself. Otherwise, it could move right out of the bird, for example. So this is a small little contentious dialogue. It's not meant to be deep or philosophically conclusive. It simply illustrates how something like this could play out. It doesn't look, at least on the face of it, very schematic. And there's another important point, namely, the topoi themselves are theoretical units. No speaker in a dialogue cites a topos in order to justify a move from, say, line 1 to line 2 on the scoreboard of the dialogue. So keeping score of a dialectical conversation does not involve referencing topoi explicitly. That's why I think we're justified in thinking of Aristotle's topics as a real logical theory, that is, a theory that is doing something other than what the arguers do. There's one last example of a genus term, but I'm going to skip that one for now and just cut to the chase, because I know we want to try to make up some time. So what are the take-home messages from this talk today? Well, one is that the topoi in Aristotle's topics can serve to identify semantic and pragmatic conditions for the consistency of a statement interpreted as an instance of one of the four predicables. Notice that the predicables basically provides you with an exhaustive list of how you can interpret an utterance, something that's really useful when you just enter something, say, in ChatGPT, or enter an utterance out of context, which must be interpreted, and you want to do something with it. They originate as a control for the results of deduction through a procedure of discussion, particularly debates, as was originally supported by a method of division. If you look, for example, at Plato's late dialogues, the interesting history and difference between Plato's dialectic and Aristotle is a topic for another time. I talk about that in the larger project of which this is a part. The conception of Aristotle's topics as based on a theory of argument schemes fails to account for this specific dimension of the theory of dialectic, and Toulmin did not have a general theory of predication for relating data to claims, but Aristotle did. Thank you very much.
Thank you. We have more than 10 minutes for discussion. Yes, Lucas.
Now? Okay. Thank you, Colin. Now, I need some reassurance that I'm not a simpleton, a naive debater, because I completely missed the point about the opposites and contraries. And you also referred to a seminal paper by Marco. So I really do not see how this argument needs of some further support, and why is it gappy. And I mean, I do not mean to say here that in the Frege sense, everything is gappy. But in a real actual debate confined within some hour or so, how can any argument not be gappy? And how can the questioner or the answerer ask for some further premises to get filled in order to concede that if the one, then the other? I have completely...
Okay, well, those were many questions, but...
Just one. Say that the answerer, and I concede that all G's are P's, and that there's some F's which are all G's. So how can I escape?
Okay, so the challenge is that every argument is gappy, so how to ever have a non-gappy argument? Or?
How and why this argument might be depending on pragmatic reasons or being gappy?
Well, so if I just ask you, is knowledge of opposites the same? And you say yes, and then I say, well, then knowledge of contraries is the same. I'm presuming that contraries are a species of opposites, and that's a premise that could be checked, right? That's something that you could reject. You could say, for example, no, contraries are not related in that way to opposites. So I guess we're assuming what a term means, right? We're actually assuming what several terms mean in these contexts. And without getting into the details of Plato's dialogues and how to find examples of this, people are allowed, also on Aristotle's considered theory of dialectic, to ask for the explication of a term. And as we know from Sophistica Elenchi, chapter 6, one of the ways that deductions can fail in dialectical contexts is through the equivocal use of terms. What is the answer to this? So how does deduction on this considered view work out? Well, Marco has an interesting paper also on this, on Sophistica Elenchi, chapter 6, but it seems that the take-home message is that you must be able to explicate the terms, and you need semantic stability which goes through so that the deduction is actually a real deduction, right? But if you're asking the deeper question of like what supports the semantic stability of linguistic terms in their context of use through a dialogue, well, that's a pragmatic question, and that's going to be part of the common ground, namely what I know, you know, I know, and you know, I know, you know. That is part of context. And because that's an important part of deduction in conversation, I think that we need to bring that entire realm of theory to bear on Aristotle's topics, because I think he's actually also aware of this problem as well.
Depending on the rest of the question, I reserve my privilege for a follow-up.
We have two more questions, so please. Okay. Professor Rapp?
Yes, mine is really very short. I was also surprised that you tried to explicate the term of syllogismos in the topics by example from 1A, which is a division.
Yeah.
I just wanted you to say a bit more what is implied by that choice, and whether you would like to recommend the division is like a paradigm case for what is going on in the topics. I have a suggestion that I was not aware of until recently, when I think this Titan 1 Aristotle suggests suggest for the question to suggest divisions as questions. So if you reconstruct 1A as a series of questions, and this be subdivided into A and B, and this be subdivided into this and this, then this would be the sense in which 1A would provide syllogismos as we know it.
Thank you. Obviously, for a dialectical context, you need to operationalize the premise in terms of a question, because premises in the topics are questions. So that's an important point. Thank you. And yes, basically my intention in highlighting this is to say against people like Heinrich Meyer, who say, oh, no deduction in the topics, he has no idea what it is, that, okay, here's a very clear example of a deduction, or a thing that he calls a syllogismos. That doesn't mean that that's what all the deductions in the topoi are about, but that means that he clearly is operating with a concept of deduction which is quite broad, and which means any kind of logical sum. So people who would, kind of press me on this point, authors from the tradition of saying there's no theory of deduction, maybe people like James Allen would say, okay, you got lots of arguments in the topics, but you don't have any annotated arguments. You don't have any arguments that are explained as arguments, and you don't have anything that's explaining the features of these arguments. And in a way, I think Marco's really great paper puts a little pressure on this as well by saying, okay, there's lots of assumptions that are just unclarified, and Aristotle doesn't seem to want to clean them up in the topic. So this is deficient in some way. And I want to take that example and say, okay, well, here's a really clear example of a syllogismos as a logical sum, namely, you accepted these premises, well, this is what you got when you're done. So I think that actually goes through into the topoi, because you accepted that. I interpreted your utterance this way. Your utterance implies the following interpretation, given what a G term means. therefore you contradicted yourself, or you at least are off base with regard to the really regulative part of the topics, which is the rules of division, probably. Certainly the rules of how definitions get constituted.
Thank you, Colin. I'm curious about the topos that you gave about the genus. And so you said, or the topos, it kind of instructs us to look whether when someone has claimed that a given thing is a genus of another thing, then check whether that thing is in fact said in the essence, N2TSD of that thing. And my question is, what do you think was the intended audience, or who are the people that Aristotle thought would be able to engage in this discussion? Because then who would be able to have a position and say, no, this is said essentially, or this is not said essentially? I mean, it's a very deep philosophical question. Aristotle doesn't ever give us the essence of human. I mean, he says biped, but clearly he didn't mean it seriously. So when and how do you think Aristotle thought that would be a useful mode of argument, and who was expected to be able to participate in those debates to make a pronouncement on whether or not a given feature is an essential feature of something?
Thank you. That's a great question. So in some slides that I deleted from this because it was already too long, I had this little debate between Solmsen. It's not a debate because he just had a view on this, which was that the theory of dialectic was for people who were discussing the results of divisions. So this is a very specialized group on that account. These are people who actually have done some scientific investigation and are now testing the consistency of their results with the topoi. That's plausible because, look, if you read, say, the beginning of Aristotle's physics, he's using topoi to test the results of other people's theories of like what space is and place is. And so this testing the result of a scientific investigation is one plausible context of use. Brunswick disagrees with this. He thinks that there were no experts here, and this was just open debate. Now, as we know, the topics also has a little chapter about what it's good for. It's good for gymnasia. It's good for investigating the principles of science. It's also good for encounters with the group. Actually, he says he's only got 3 uses, but he actually has 4. It's also good for knowing both sides of a question. So it seems like that particular passage, topics, I think 3, is kind of open on this. It could have been the testing of scientific results according to the standard of a scientific result, at least in the academy, namely, does it capture the essence? That's what you want to get, right? That's the good scientific result. It seems that for gymnasia, for training, you could simply train people in argumentation. And, you know, if you've ever been caught off base, that is, if anybody's ever shown you that you're inconsistent, I can tell you it's a very efficient way of making you more logical. So it could also be a kind of logical habituation game. It seems to me like those possibilities are open, but certainly when we get to book Delta and we're talking about essences, it seems like a very specialized kind of debate.
Thank you. So we have time for just one more question. Yes, please.
Okay, it will be maybe not a question, it will be a comment from AI. Because it was a very interesting lecture, and I've seen that there are some actions which we already doing with agents, with this stuff. Basically, we are using kind of the theory which is named the theory of mind. When we try to mimic what we say in this chain of I think that you think that I think that you think, right? And this is what we try to do using the different models. So there are a couple papers about that. In different contexts. Probably not such philosophical context like Aristotle papers, but it's in the practical context of science or innovation or not only the arguing or disputing about one topic, but also investigating new ideas. So this is just a comment that maybe it's worth, I would say, to look there, and maybe it will be a nice connection.
Yeah. Thank you so much. I mean, just my little experiments with AI has taught me that, I mean, on the difficulty of these capturing the pragmatic and semantic content of an utterance in a context of use, which is basically what the topics is also trying to do, because the predicables theorize the content of an utterance, right? They give interpretations of the content. That's a very difficult thing. And if AI can do that, whatever we mean by AI, and I'm leaving that open because you guys know about that, I don't, that's a remarkable achievement. And I think, however, we can appreciate Aristotle's topics also against the background of the difficulty of such a task.
Yeah. Can I,
Thank you.
Can I just, one moment, now that we're talking connections with AI, your little example with birds moving is actually the example we use also in AI 101 to say to the students, you just can't formalize general knowledge like this with strict logic, and you need dialectic argument.
Perfect. So thank you so much.
Okay, welcome to the next session, and it is my pleasure to introduce Edgar Daylight, who will speak to us on the topic of interplay of Aristotelianism and Platonism in non-deterministic computation. Thank you.
Okay, thank you very much. The outline of my talk is as follows. I'm going to distinguish between what I understand as Aristotelianism and Platonism in the context of computer science. I actually come from computer science, graduated in the year 2000. I did a PhD in software engineering. And then after my PhD, I went to study logic in Amsterdam, and then I got into history and the philosophy of computing, always with the drive to actually understand the fundamentals, or the so-called fundamentals of computing today. If I'm going to give you the impression that I am a Platonist, then I'll be giving you a wrong impression. If you think I am an advocate of Aristotelianism, then you're thinking wrong again. I'm just trying to compare and contrast and learn as I go along. So what do I understand, given my background? Well, I'm borrowing insights from Lineboy and Shapiro's paper, where they perhaps, for this community, it's perhaps a bit of an oversimplification, but they distinguish between two schools of mathematical reasoning. So the blue line of thought will be neo-Aristotelianism, and it's dynamic reasoning when it's all about executing an algorithm step by step. While if you talk to computer scientists, they will actually say that fundamentally they are formalizing everything in terms of set theory, so that would be the red part of a talk. So we have, from this paper by Lineboy and Shapiro, we could distinguish between two schools of thought, referring to Aristotle, Euclid, and step-by-step reasoning, and they talk about, in the context of geometry, what an idealized geometer can do. And so, for example, they give the example of Euclid's elements, where dynamic language is used to actually conduct your mathematics or your geometry. And then there's some tension. The contrast is with the red part, Plato, Plotinus, and then so later Cantor and Hilbert, going for a static, timeless ontology of mathematics. And so they give the example of Plato criticizing dynamic language as inconsistent, according to him, with regard to true geometry. So this, I'm not going to talk about geometry. I'm going to talk about computer science and the same blue-red distinctions. But the title of my talk is, I think, more charitable. It's about an interplay between blue and red. So I'm going to give examples in computer science where people sometimes wear their blue hat, sometimes wear their red hat, and sometimes they might not be aware that they're wearing both hats. So you'll also see the color purple coming up at some points. So, okay, again, I distinguish between a first-person perspective and a third-person perspective on how to conduct mathematics. If there's actually one sentence on this slide that I would like to erase, I would probably want to erase the emphasis on first person. But again, to make a contrast, I am presenting it nevertheless. So we have a step-by-step progression on how an algorithm or what people call a Turing machine, how that computes. You can look at that step by step, but you can also look at a Turing machine in red, and then independent of human activity, try to formalize what a Turing machine or what an algorithm is. And then you have the mathematician being the narrator, observing a timeless static reality. So we're talking about executing an algorithm, but in a timeless static way. So that's what I'm going to talk about. The mathematician as an actor or builder, again, to just make a point today, I'm going to associate this with the engineer, and then the mathematician as a narrator, actually the set theorist. And that was then my intro between the blue and the red schools of thinking. And now we have this big complicated matrix. Just look at the two columns. We have determinism. I'm going to talk about deterministic computations. So for example, if you want to find out the shortest path from here to the airport, you will actually run an algorithm on your phone, and it's actually a deterministic computation. While a non-deterministic computation at the second column is all about your computer making some non-deterministic choices as it goes along. I'll come to that later. The point is that if I start with the first column, we have people who conflate the blue and red thinking in their discourse, and that could be a harmless and maybe even purposeful conflation, or it could be problematic. And then you have people who will want to separate the blue from the red. Always add the words, add neo, it's neo-Russellian and neo-Hilbertian, but I don't want to overcomplicate my slide. So the neo-Russellian, I will claim, in computer science today, conflates the blue and red thinking in their daily discourse. And that could be problematic, or it could be just fine. I leave that up to you, but you'll notice that I have a certain interpretation with regard to this. And I'll end with the question, so what? What's the whole point of this? Determinism. So in fact, this is coming from blog posts from some renowned theoretical computer scientists. So Lance Fortnow describes a blue Turing machine. He says that when I prove a theorem involving computation, I feel the machine processing step by step. I feel it humming along, updating variables, looping, branching, searching, until it arrives at its final destination and gives an answer. And then we have Robin K. Hill, a philosopher of computational complexity theory and computer science. She will emphasize the static ontology. A Turing machine is a static object, a declarative, a quintuple of the necessary components. The object that constitutes a transition function that describes the action is itself a set of tuples. All of this is written in appropriate symbols and just sits there. I do not want to give the impression that if Fortnow would be sitting here, that he would be disagreeing with everything that's written in red. He will agree that fundamentally he is going to formalize everything in set theory, so he will agree with the red words as well. But it makes sense when you do your theory building in computer science that you actually wear the blue hat, as Fortnow himself prefers. So let me now give an example of statements in computer science textbooks where in one statement you have a part that is in blue and a part that is in red, according to my analysis. And it could be problematic or not. It's at least something I've never actually understood. 20 plus years ago, I came across such statements in computer science textbooks. You can take any one you like. They are built on a central tenet, which I call the neo-Russellian tenet. And it goes like this, from Michael Sipser's book: a Turing machine can do everything that a real computer can do. And so some 25 years ago, I was already like wondering, what is the first do and what is the second do? So I was actually maybe a small mini philosopher in a computer science department, because it's not the kind of question you ask to computer science professors. And again, to oversimplify, I'm just going to call the red the set theorist speaking, because everybody in this niche will agree that fundamentally they are formalizing in set theory. And what a real computer can do, they're talking about causal systems, things that consume energy. And they actually want to make claims about engineering. So this is also the whole point. They want to actually have a set theoretical account and then say something about the real world. Otherwise, they would actually also be less relevant in their teaching. So I call this a neo-Russellian tenet, and I've given a talk on this from a Wittgensteinian angle 2-3 years ago, and here's the link. That's just a small example of neo-Russellian conflation, if you don't mind me saying so. And then we have the neo-Hilbertian way of wanting to separate the two, at least according to my understanding of David Hilbert's views, which I primarily got from this book by a mathematics educator, giving a nice explanation on an emancipatory movement in the history of modern mathematics. So he talks about pre-counter versus post-counter, practical methods based on natural experiences towards an Hilbertian ideal, so another way of conducting mathematics and science, theoretical mathematics grounded in definitions and proofs. But until thus far, I've always suggested that the red I will associate with Neoplatonism, but I should be careful now because the whole point of the Hilbert program, in my understanding, was to step away from any philosophical position and go towards nominalism. And I would like to actually talk about this for people who know more about this after the talk. But I'm going to continue distinguishing between blue and red. So David Tall, in his book, writes about a total reversal in the history of mathematics. Instead of studying objects or operations that have natural properties, the chosen properties, actions are specified first, and the structure is shown to have other properties that can be deduced from the actions. And when I consult the two black books, Scott Berman defending Platonism and then James Franklin defending an Aristotelian form of mathematics, these two authors will want to put more nuance on these sentences coming from David Tall, but I'm not going to delve into these books today. But this is an excellent book by James Franklin on mathematics and his view towards mathematics. I want to stress the bold-faced words, not the blue and the red this time. It's about instead of studying objects or operations that have natural properties, instead of working in blue, we're going to work in red. And that's a contrast with the neo-Russellian tenet I showed you a few slides back, where apparently computer scientists are working in blue and red at the same time. And then once I started noticing this, I go look at books written by software engineers who will actually also want to disagree in their own way with the neo-Russellian tenets. At least, again, in my understanding, they will want to distinguish between the blue and the red. And this might come as a surprise to this community, but here we have a professional software engineer, Edward Lee, who is actually giving the Hilbertian view on engineering. So this is what he says: many predictive properties that we assert about actual computer systems, such as the properties of determinist timeliness and reliability, are in fact not properties of an implemented system, but rather properties of a mathematical model of a system. We can make definitive statements about models from which we can infer properties of system realizations. The validity of this kind of inference depends on model fidelity, which is also always approximate. So what I'm trying to say is that if we look at the literature at large, we see some professionals, and pretty late in their careers, by the way, starting to realize that we should not conflate our mathematical findings with the real thing, because they are actually always embracing the red line of thinking. So I understand that in this community, in fact, this book by Franklin gives a total different view on this kind of statement. So but I don't have time to delve into this. So this was determinism, where we see people conflate and we see people want to separate the two ways of thinking. Let's have a look at non-determinism. And there's no need to read all of this, but this again comes from Michael Sipser's book, A Definition of a Non-Deterministic Turing Machine, with a state Q and a power set P. So this is all set theory. And I'm just going to scrutinize the underlined words. The computation of a non-deterministic Turing machine is a tree. I'm going to try to find in the theory building itself examples of red statements, blue statements, and purple statements. Because why wouldn't they also be mixing up things in their own theory building? So that is a bit of a provocation. And I repeat, so the definition in Michael Sips's book says that the computation of the machine is a tree. And then I try to picture a tree myself in 4 different ways. And so the red figures are just in conformance with my understanding of set theory. You don't have a notion of time. And so the top left figure is already, in my opinion, better than the top right figure where you have the arrows and you're actually in an Aristotelian way, again, in a neo-Aristotelian way in this particular context, thinking spatio-temporally about top-down executing a non-deterministic algorithm, and so certain choices are being made at these choice points. So I shouldn't have done that. Now, I don't want to go into the other red ways of representing with static ontology in mind the notion of a non-deterministic algorithm, so I'm just going to distinguish between A and B going forward, and I'm going to try to explain in just some pictures and colors how people in this community, computational complexity theory, formalize notions such as the P and P problem and NP completeness and these very big mathematical problems. In my opinion, they officially start with set theory, so something on the left, but they actually always reason in blue. They told me this in reaction to this talk, so they will want to draw these arrow pictures, but then they will want to crystallize, they will want to hypothesize an accepting computation path through that blue figure, and they're going to formalize this in a propositional formula, that's A of W. So they're going from blue to red, to set theory. So I'm showing that in purple. And so the way I take this is that we're talking about a Platonic reinterpretation, that's the top right part of it, so that's part D in the figure, a Platonic reinterpretation of an Aristotelian correct guess, that's B and C in the figure, within a Platonic graph of deterministic computations. This is how I try to conceptually understand the interplay between set theory, which sits in the first row in this community, and then the Aristotelian way, which is very much present because we're talking about algorithmic thinking. So I guess what I want to convey is that if you would push me on this, I would say that the official definition should not contain the word tree, but should contain the word graph. But this is like a subtle point. You can still ask, so what? What is the whole point of this? Well, let me give you 2 pointers in the context of determinism. So that was the first column in that matrix. If you become very picky about the blue and the red and the purple, you could, so I've published about this, you could go from a blue raw machine, so something that moves step by step, and that looks like this, it has 3 tapes. You could actually formalize this in red in 2 ways, not just in 1 way. So the first way is the traditional way in the textbooks. You're going to formalize that with the notion of a Turing machine computable function. While the second way is the one I then propose. You could formalize that just in a delta different way, slightly different way, respecting all the rules that are in, well, all the conventions that are supposed to be respected, and you have the notion of a refined Bergen machine, an RBM computable function, and you can prove mathematically, again in set theory, that there are more, well, that every Turing machine computable function is an RBM computable function, but not vice versa. And the idea here is that if you embrace number 1, the mainstream way of thinking, you are actually, again, conflating, in my opinion, Aristotelian way of looking at a running machine in blue and one particular way of capturing that in red, because the idea here is that a halting Turing machine, a halting blue machine, reveals the complete results that it has produced to the outside world all in one sweep. So while I would like to then, in this case, actually be a bit more Aristotelian, I would say that an RBM machine provides the first output symbols for the outside world to see as soon as they have been computed. If we're going to distinguish between, if we're going to accept this step-by-step notion of a computation with regard to the work tape of a Turing machine or of a raw machine, then we could also embrace the step-by-step production of output bits on the output tape. Why would we all of a sudden then just simply abstract away from that? What I'm saying is that theory building can be done in different ways depending on your conceptual choices that you wish to make. Injecting observers into computational complexity is a forthcoming paper where I address the so what question in the context of non-deterministic computations. Here we have on the left a simple string rewriting system which can be defined with a very simple grammar. Again, the essential point here is that it illustrates non-determinism. You see that certain paths diverge and some come together. And you can capture this with a very simple system. And in contrast to the mainstream literature on computational complexity, some researchers 20 years ago looked at this kind of computation, this non-deterministic computation, and injected the notion of an observer into the mix, which is again a very simple system in set theory with just a finite state machine. And by having a string rewriting system on the one hand and an observer on the other hand, the observer will actually, as is shown on the right-hand side of the slide, the observer is going to actively prune away several computations in that tree on the left-hand side, and is going to say, I like this and I don't like that. And if you put those, if you look at computation in this particular manner, you get what is called computing by observing. So this is a niche in theory, in the literature. And you get, what is happening is you have what I would say Aristotelian activities of string rewriting and observing, but once again, what they always do is they go to a red formalization. My point is that you could formalize this again in more than one way, not just the first way. You could do this in a second way, and you will actually come up with with something new. I'll come to that in a moment. So the first way is a traditional way with a theorem from 2000, from this century, but with a beautiful survey article by Peter Leupold, where you get Turing completeness by simply having this very simple string rewriting system, which is a context-free grammar. That's what I mean with simple. And you have this notion of observers. These are just finite state machines. So just putting those two simple ingredients together in their observing paradigm, you get Turing completeness. So I realize that now I'm putting a lot of jargon into my talk. And then I have a theorem that I extend this theorem one from determinism to non-deterministic computations. And then, again, we can go for a totally different formalization. And then the end result is that I propose a novel way on how to simulate a non-deterministic Turing machine. And so this is coming in the literature. So I guess if there is a takeaway, I would say there is room to wear different hats, a blue one, a red one, sometimes a purple one, and be picky about somebody claiming that there's only one way to go from blue to red. There are actually two or more ways. And I realize that in this community, you might want to get rid of the red and work fully in blue. And I'm totally open to that, as I said in the beginning of this talk. But I'm trying to actually communicate with the mainstream computer science people. So thank you very much.
Thank you. So questions, yeah.
Thank you. This was quite stimulating. Thanks. I have a suggestion and a question. Could this be made to related to Moskovakis' idea between the distinction between algorithms and programs? The algorithms representing the Platonic point of view and the programs that implement them, the Aristotelian point of view. Okay. So this is the first question.
Yeah, so if I would show the rest of the whole paper, I will give examples of programs. So a program implementing, for example, a non-deterministic algorithm. You'll see people in that niche reason even much more in blue. So Bob Floyd is an example. But that will, let me just say two things. I can easily find examples of people who reason about programs, computer programs, again in red. But I agree with you that if we go to computer programs, so now we're talking about the community of programming language design. So Ray Turner is a big name in this field. He is willing to step away from the red and go back to what I would then call blue. Right. Yeah. Yeah. But he's a bit in conflict with then mainstream computability theory, where they will want to work in red.
Right. You're referring to the Russellian, the set theoretic point of view in a broad. This is broadly construed, right? For the definition for the Turing machine quintuple, we need way more than the belongs to predicate. So, and I guess you're referring to a certain kind of idealization of the Turing machine, where this is eternal and Platonic, and the need to introduce direction in the machine cannot be achieved unless you put other symbols than the belongs to symbol. So in order to describe the step-by-step computation.
Sorry, we can talk for hours after this, right? I mean, we will do that, right? But so let me just give you the reaction of a peer reviewer who was probably a computational complexity theorist. He said, I mean, you learn from the reviews, right? So he said, we learned from Turing in 1936 that the blue step-by-step of a Turing machine and the red extensional reasoning with the functions, that they're the same. That was his claim. I'm going to agree with him because I want to get the paper accepted for other reasons. But I want to write another paper where, I mean, this is opening a whole can of worms. I would say that Turing was asked in 1937 by Alonzo Church to connect the blue step by step, because originally Turing only had the blue, and he was asked to add an appendix and make it connect to the red of Church. And I'm saying he could have done it in another way. That's really provocative, but I know you accept this kind of statement. But saying this in the computer science community would be very provocative. And then I address this historically in my writings. We see how Turing might have thought or might not have thought. I don't know if I actually answered your question.
It was just about the formalisms. Yeah, you did, but it's more confined to the formalisms that we did more symbols than the belongs to symbol.
You mean set include? You mean belonging to set? Or?
No, in order to describe a Turing machine.
Yeah.
In the formalism, we have more non-logical symbols than the belongs to symbol, which is set theory. Well.
Oh yeah.
Okay, it was just, but the essence of my question was what you said, and thank you.
Yeah.
I really appreciated your advocacy for the blue team. I'm curious about the last slide, the second strategy of going to the red team. So could you maybe explain a bit more how we then transition to a perspective of propositional logic?
You mean this one?
Yes, exactly, the second Platonic lens. Could you say
a
few words?
I can give you the paper. Well, do you want me to explain? I don't know if I should do this.
Just maybe the role of propositional logic vis-a-vis the blue team. So
okay, yeah, no, you might now catch me on something. I'm claiming here, let me just assume we're the only ones in the room. I'm claiming that propositional logic is fundamentally expressible, formalizable in set theory. Okay, you're still nodding. And then the blue, well, that is again informal. In this community, it's informal intuition on what a computation is. And if I explain how they do it in automata theory, and I give you the whole formalization, you already get this nice string completeness result, as I alluded to. But then you can ask yourself, what if I now try to follow Michael Sipser and Stephen Cook in how they use propositional logic to capture satisfiability? So they're already doing the blue to the red in the bottom right corner in their context of non-deterministic computations. They're not doing it in this context of the computing by observing paradigm. So I'm playing their game, but with this paradigm, and I need to capture notions of an observer in propositional logic, and I use horn clauses for this. And I need to capture the string rewriting. I use horn clauses for this. And I'm going to end up with one sub-formula which I cannot capture in a horn clause, but for which I need a genuine 3CNF formula. Because if I could have done that in horn, that would be P is NP. I mean, then I wouldn't be standing here. Okay, but that's not happening. But I do. This does lead to a beautiful result that now you only need one sub-formula that is still a genuine 3CNF formula. All the rest is in horn because of the frugality that is present in this whole paradigm. As I tried to explain in the beginning with the string rewriting, which is very simple, in the Chomsky hierarchy is very simple, and you have an observer which is just a finite state machine. So that's a notion of efficiency that can be expressed formally with these horn clauses.
Thank you.
We still have time for more questions, but I don't see any.
So I do recommend this book. You can come to me and have a look. James Franklin, maybe you know him. Okay, thank you.
Then thanks again. Here Zoe McConaughey from Lille, who's going to talk about a formal reconstruction of Aristotle's esoteric syllogistic.
Okay, thank you. So first of all, my warmest thanks to the organizers for this rich and stimulating symposium. I will be here presenting the main lines of my formal reconstruction of Aristotle's syllogistic, esoteric syllogistic, not the modal part. So this reconstruction uses the language of Per Martin-Löf's intuitionistic type theory from 1984, which is also known as constructive type theory, CTT, or Martin-Löf type theory. It is built within the framework of Paul Lorenzen. Well, my work is built within the framework of Paul Lorenzen and Kuno Lorenz's dialogical logic, which Christoph Rapp mentioned at the outset. And more precisely, I will be using the variant called immanent reasoning, which incorporates notation from constructive type theory into the dialogical framework. I have developed this reconstruction in my PhD dissertation, and I will be publishing it with Bloomsbury in 2026. The language used, so, is that of constructive type theory by Per Martin-Löf. It is a language of proof theory. It is a typed language, which is common to logicians, mathematicians, computer scientists, and we can also add linguists in there. So logicians and computer scientists can use the exact same language. I will add here that I am on the logical side, and I'm not a specialist of computer science. The fact that this language is a common language can be seen in proof assistance. For instance, Agda, which is developed by Chalmers in Sweden. And the proof assistant Agda is directly built on constructive type theory. So CTT, constructive type theory, implements the Curie-Howard correspondence. In this setting, a proposition can be seen as a set or a type, and a proof is a program, or a program a proof. Part of my work consisted in translating Aristotle's esoteric syllogistic within the language of CTT. Among previous work, is that of Jan van Platteau's 2016 paper, Aristotle's deductive logic, a proof-theoretical study. He develops a proof-theoretical approach to Aristotle's assertoric syllogistic. My own reconstruction is quite close to the semantic interpretation he develops. So let us have a look at it. Here are Aristotle's 4 types of predication. Universal affirmative, every S is P, every human is an animal, which is named A predication by the scholastic and pi plus by von Plato. There's universal negative, no S is P, no human is a rock. The E predication of scholastics, pi minus for von Plato. Particular affirmative, so some animals are humans, some S is P, which is I predication or sigma plus. And particular negative, some S is not P, so some animals are not humans, O predication, sigma minus. Von Plato uses Aristotle's dictum de omni et de nullo to provide the meaning explanation of universal quantification. Such an approach is further developed by Mathieu Marion and Benoît Castelnerac in a 2019 paper, which focuses on a dialogical standpoint. This passage, the dictum de omni et de nullo, is a small passage at the beginning of the prior analytics, where Aristotle says, we use the expression predicated of every when none of the subject can be taken, of which the other term cannot be said. And we use predicated of none likewise. So, for the universal affirmative, there is no instance of the subject, there's no C of type S, such that it is not an instance of the predicate, that is, such that P of C fails. For the universal negative, there is no instance C of the subject, C of type S, such that C is an instance of the predicate, that is, such that PC. So it's a no counterexample or no objection interpretation. You cannot find an objection for the universal affirmative or for the universal negative. I extend von Plato's notation in order to have the underlying instance always present. However, I embed this language notation within the framework of dialogical logic. So first, for universal affirmative, we have von Plato's notation here with the instance C, which is explicit, but I want a dialogical framework. So I add a player, here X, who will be making a statement, which is symbolized by the exclamation mark. And I want to generalize what is being said. So I don't just want an instance C, I want any instance. So I use here the universal quantifier, the pi, to generalize the instance, to have any instance at all. And let's have a closer look to this generalized form. So we have the player X who states, here, X states, then we have the subject part, this is the big parenthesis, and then the predicate part. So there's 2 big parts. In the subject part, there's the universal quantification on a certain Z, which doesn't really exist. It's useful for this here. So we will be speaking of the instance, which is the same in the subject and in the predicate. So we have to choose an instance, which is of a certain domain, such that the subject is said of that instance. So it's an instance of the subject. And the predicate will be said of the instance, which is chosen here on the first part of Z. So Z here, it has 2 parts, a left part, a right part. The first part here is this part. So we choose an instance, and it will be one of the subject and of the predicate. For the 4 quantified propositions, we have very similar expressions here. The meaning of these expressions is provided in the interaction rules of dialogical logic, which is how a statement can be challenged, how it will be answered, and how the challenge can be answered. So at this point, I need to introduce an overview of the dialogical framework. there are in the dialogical frameworks, there are two players, a proponent and an opponent, who will challenge each other's statements and defend the challenges. The players interact according to game rules. There are two types of game rules. The interaction rules are player-independent rules, like the moves of chess pieces, which are the same for black or for white. And the interaction rules determine the appropriate interaction, challenge, and answer for each kind of statement. The structural rules are player-dependent rules. They determine the general structure of the game, how it starts, how it proceeds, how it ends. A core feature of the dialogical framework consists in its two levels. There's the play level, which is the most important level. It is the level of interaction between the players according to the game rules, interaction and structural rules. It is finite and thereby always decidable. A player wins after a finite number of moves. The strategy level is then built on the play level. So you take the proponent and see if he can win whatever the opponent may do. It's like checkmate in 5 moves. It's the same kind. Whatever the other person will be able to do, I will have a way to win. It's a dialogical equivalent to proof or validity. And this level is not always decidable. For instance, first-order logic is not decidable at this level. So now, a final thing before we proceed, a precision on the relation between the dialogical framework here and the Aristotle's dialectic, which we have already been discussing. So in dialectic, the answerer defends a thesis. The questioner challenges it. And at the end, the questioner can force the answerer to accept a conclusion answerer does not want to accept, and questioner does this through a syllogismos, or deduction. From what you said, you must commit to this conclusion. The French Aristotelian specialist, Michel Trubelier, argued that the syllogismos is a moment in a debate where the questioner stops the discussion and says, now, from what you have said, you must accept this conclusion. It is a recapitulation moment. He recapitulates what the other has said, which is relevant for the conclusion. This is important for the switch to syllogistic and the dialogical framework. Under this interpretation of syllogismos, syllogistic is the systematic study of this recapitulation moment. So the questioner becomes the proponent in dialogues. He defends the syllogismos. From what the answerer said, the conclusion follows. And the answerer becomes the opponent in dialogues. She tries to resist and show that no, the conclusion is not necessary. She does not have to commit to it. And we'll see, in the valid syllogistic moods, the proponent wins. He actually has a winning strategy, whereas for the invalid moods, opponent wins. So here are the interaction rules which provide the meaning of the different quantification. So the interaction rules for syllogistic are an application here of the no counterexample interpretation of the dictum de omni we talked about, and they are at the level of ecthesis because we have to choose an instance. So when X, a player, makes a universal affirmative statement, the challenger Y can choose an instance D and states that the subject holds of D. So the challenger challenges the subject part by stating an instance of the subject. And the answerer answers the challenge by saying that the instance chosen by the challenger is an instance of the predicate. That's the meaning of saying for all. For universal negative predication, for a particular affirmative predication, the challenge consists in asking the X to choose an instance, and then the challenge consists in agreeing to that instance, and the answer to the challenge will finally be saying that the predicate holds of that instance. For the negative quantification, it's basically the same for the universal. The challenger has the choice of the instance, but, the answer states that if I have to say that D is an instance of the predicate, then I quit. It's the negation here. And for the particular one, it's the person who makes the particular statement who chooses the instance and says that the predicate holds of that, does not hold of that instance. And we have here a rule for negation, where if I state a negation, the challenger says, for the sake of the argument, that the predicate holds of that instance, and if we have to answer this challenge, we commit to losing. So it's bottom here for abort the program, or I quit, I lose. Before looking at a few proofs in the time we have left, let us look at the structural rules. There are 5 structural rules for syllogistic. First, the starting rule just says that the proponent P is the player who states the thesis. In syllogistic, the thesis is a claim that the conclusion holds, provided that the opponent endorses the premises. So it will be a dependent, the conclusion will depend on the premises. Such a conception of Aristotelian syllogism, as I said, is based on Michel Cruvelier's interpretation of syllogismus as recapitulation moment. So the play then proceeds with each player either challenging or defending in turn a move according to the interaction rules. The Socratic rule then puts a restriction on the proponent, who must base all of his elementary statements on those of opponent. This is necessary for if proponent is to ground his statements in what opponent has already endorsed, and in that only. So he cannot add anything new to the discussion. Then there's the pragmatic coherence rule, which deals with a special configuration, but we will not have time to go in that. And finally, the play ends either when a player states bottom and quits, or when a player has no available move left at his turn and that player loses. So let's look at some proofs. Here is the play for Barbara. So we'll go step by step because I favor the blue approach. So Barbara, it's 2 universal affirmative premises, a universal affirmative conclusion. So that's the well-known syllogism. All animals are mortal, all humans are animals, therefore all humans are mortal. How is it built? The proponent starts by stating Barbara, so the conclusion provided that the opponent states the premises. The opponent then concedes the premises, which I have written here in fully developed form, with the underlying instance present. Proponent then states the conclusion. Opponent challenges move 2 here by challenging. So how do you challenge a universal affirmative? You choose an instance and you say that C applies to that instance. So you claim that C holds of D. It's proponent's turn, so in order to answer this challenge, proponent would have to say that A holds of the instance chosen, so A of D. But opponent has not yet stated A holds of D. So according to the Socratic rule, proponent cannot answer right now and must force opponent to state A holds of D in order to answer this challenge. So he cannot answer the challenge, but he can challenge here the premise 1.2 by choosing an instance, the same, and saying that C holds of that instance, which opponent just said. So here we have a grounding of proponent's claim, you at move 3 just said that C holds of D. So now show me that B holds of that instance, which is what opponent says when answering the challenge. It's proponent's turn, who can now challenge the first premise by choosing still the same instance. You at move 5 said that B holds of D. So now show me that A holds of D, as you claimed in 1-1. At move 7, opponent answers the challenge by saying that A holds of this instance, A holds of D. In its proponent's turn, there was this challenge which was pending, there was no answer yet, and now proponent is capable of answering the challenge by saying, you at move 7 just said A of D, so I can now say A of D. And it's opponent's turn, she has no move left, so proponent wins. Since opponent could not have played otherwise during the game, proponent has a winning strategy for Barbara here, for the syllogism. Barbara is thus justified through the interaction rules based on the meaning of quantification spelled out in Aristotle's Dictum et Omni and Ecthesis. Now, for E-conversion, so if no human is a rock, if no human is a rock, then no rock is human. So we have the same structure. Opponent concedes the premise. Proponent states here the conclusion. Opponent will challenge move 2 by stating here, by choosing an instance and stating that the subject holds of that instance. It's move 3, A holds of D. Proponent is capable of answering immediately this challenge that B holds of that instance because it's a negation, so it's not an elementary statement. So B does not hold of D. Opponent challenges this negation by stating that, yes, let's say for the argument that B does hold of D. And now if proponent is forced to answer this challenge, he's forced to quit, to abandon. So he's not going to challenge, to answer the challenge. Instead, he challenges move 1 by saying that at move 5, you yourself claim that B holds of D. So opponent now answers the challenge by saying that A does not hold of D. But proponent can then recall that opponent move 3 said that A holds of D in challenging this negation. Opponent has no other move than answering the challenge by stating bottom and therefore quitting, abandoning the game. So here again, opponent has no other choice during the game, so proponent has a winning strategy. I would like to stress here again the difference between the two levels of the dialogical framework. The strategy level, which is the level of valid syllogistic moods, is the level of proof, where proponent can win regardless of opponent's choices. And for syllogisms, she has no choice. This strategy level is built on the play level. And the play level is where interaction takes place according to the game rules, and the game rules determine meaning. So the strategy level is based on interaction which embodies meaning. Meaning is determined, and the play level is where, the meaning determined at the play level is determined independently from the valid moods. So the valid moods are valid because of the meaning, but the meaning is not determined because of the valid moods. And this fact is visible with the invalid moods, because we will be playing in the invalid mood here, we will be playing with the exact same rules of interaction in the game rules, but proponent will not be able to win. He will therefore not have a winning strategy, which is what we're expecting for an invalid mood. So let us look at this game for an invalid combination to see the contrast. Here it's premises AE and conclusion A. So, for instance, every animal is mortal, no rock is an animal, therefore every rock is mortal. This is not valid. So, how does it work? Same rules. Proponent states the thesis, opponent states the premises here. Proponent then states the conclusion. Opponent challenges this conclusion by stating an instance of the subject here, C of D. Proponent cannot answer immediately this challenge because it would require stating A of D, which opponent has not said. So the Socratic rule prevents him from answering. But he can challenge premise 1, 2 by saying, well, I'll choose the instance D, which is an instance of the subject C of D, because you just said that C holds of D. Opponent answers the challenge by saying B does not hold of D here. And opponent wins because proponent cannot answer this challenge because opponent has not stated A of an instance, A of D. Proponent cannot challenge this negation because opponent has not stated that B holds of D. And proponent cannot challenge the first premise because it would require saying that B holds of an instance, and opponent has not stated that. So proponent cannot play, and therefore opponent wins. So the rules based on the dictum de omni and ectasis allow to show why the invalid moods are not valid here. Proponent cannot give an instance of the subject B of premise 1.1 by grounding his statement only on opponent's own statement, or answer here, or challenge the negation. In other words, here, opponent has a lot of choice. And so she can use these choices in order to block proponent. So, to conclude, in this brief presentation of the dialogical reconstruction of Aristotle's assertoric syllogistic that I developed, we have seen how constructive type theory notation enables to make explicit the instance underlying Aristotelian quantification. We have seen that the interaction rules are an implementation of the dictum de omni and of ectasis, and that the structural rules implement the recapitulation conception of syllogisms. We have also looked at two games with a winning strategy, the game for e-conversion and the game for Barbara. And these games can be compared with one without a winning strategy, won by opponents for an invalid non-syllogistic combination. The same rules can thus be used to prove the validity of conversions and of syllogistic moods, and the invalidity of the invalid moods. It also shows that propositions and meaning in the dialogical framework are based on interaction and not on truth or proof. In my work, just to be sure, I have gone through all the valid moods in all three figures, in all the invalid combinations as well, also in all the three figures, just to make sure that the rules work, and they do. I have also reconstructed indirect deductions and reductions to the first figure, which both involve additional structural rules, but there was no time here to present this. So, as a final note, I would like to touch upon the big question here. Why formalize Aristotle? For me, going back to Aristotle again and again is a goal in itself to better understand his thought. But also, it forces us to reflect on the principles which structure our contemporary frameworks. What I mean is that syllogistic can be formalized in many different ways. The question then is, what kind of formal reconstruction stays closest to Aristotle's own way of doing and seeing logic? This forces us to reflect on our own frameworks. What do we do when we say, what do we say and what do we do when, with our logical systems? What conception of reason, of language, of the world is embarked in these systems? So reflecting on Aristotle, which grounding principles are closest to his views, is at the same time a way of reflecting on our own frameworks. But what is more, going back to Aristotle and try to translate his logic into one of our contemporary frameworks puts constraints on our practice, constraints that are actually very fruitful. These constraints force us to further develop our contemporary frameworks. So there are two ways to look at things. One, and I'll finish on that. One is a pessimistic way. Aristotle's dead, and we don't know what his conception of logic was. We can only interpret his logic. We do not know what he actually thought. And our contemporary tools can only introduce bias because it wasn't what Aristotle did. The optimistic way, which I take from Paul Lorenzen's approach of dialogical logic, is that by going again and again to the text, we can understand it better. And our contemporary tools can help us ask questions to the text in a fruitful way. And trying to reconstruct this interpretation of Aristotle's text can bring us to find new paths and new tools in our contemporary frameworks. So I invite you to follow this second approach and read Aristotle to better understand him and try to bring new ideas to logic today. Thank you.
Thanks. So we have roughly 15 minutes for questions. Yes.
Yeah, thank you very much. I wanted to ask about the role of the constructive type theory. So you mentioned the system that was given by von Plato. And the proof-theoretic system that von Plato gives, it doesn't incorporate the type theory into the proof system. It just deals with these categorical propositions, the sigma plus and the pi plus and so on. And von Plato views the type theory formulation as an account of the semantics, but he keeps the semantics separate from the proof theory. Whereas in your system, it seems to be all integrated. So I wanted to ask why you went this route, why you decided to depart from the von Plato framework in this respect.
So von Plato's, it's what I said is that my approach is close to von Plato's semantic interpretation of Aristotle, which is based on the dictum. And so my objection to von Plato's approach is that he gives a semantic interpretation of the different quantifiers, but then doesn't really use it in his his proof theoretical system. In the dialogical approach, we have a framework that's semantic through and through. We don't have a separation between syntax on one side and semantics on the other. That's why the interaction rules are really important, because they at once give the meaning and the way it is used, and so the structure also of the different propositions. So I took in von Plato only what I thought was the most useful, which is the semantic part, and I developed that part to make it fully explicit, and that constructive type theory is very useful to make things explicit. So in my approach, I use constructive type theory as a language tool, linguistic tool, to make things explicit, and then that is what is used in the dialogical framework, where the meaning is based on interaction, how to challenge, how to answer a challenge.
Thank you.
Lukas?
Enthusiastic I am for the conclusion, but let me go back to the presentation. And there's, right, so I know I'm already aware of this formalization, but the real challenging thing here, one of the real challenges would be as follows. You put the syllogistic into a dialogical form, formalizing it. Now, wouldn't be a good starting point to thinking on how to formalize the arguments as depicted in the topics themselves, and thereby, for example, this already is somewhat contaminated because there is this rule that once the answerer renounces to say that no item or belonging to some class has a certain property, then the questioner can make a parade and say, provide me with a counterexample, right? In a finite Aristotelian universe and between two idealized opponents, the search could go until the class is exhausted. So this specific guidance is already in the topics. So couldn't we start thinking to enlarging this by allowing the answerer to put pressure on the validity claims by the questioner? So to challenge whether or not the claim by the questioner that this follows from that is well grounded, and such moves that would make the dialogue more like in the topics, or like people think it's in the topics.
So in this approach, I'm developing Michel Creubellier's interpretation of the syllogismos, where, so after in a debate, the questioner stops and say, okay, I've got you. From what you've said, you have to accept the conclusion. But we have to keep in mind that there's like more give and take here, because as you say, the answer can say, well, let's just wait a moment and check that indeed, from what I have claimed, the conclusion does really follow. And that would be like syllogistic, would be about that moment. The invalid moods would be, okay, from these two premises, the conclusion does not necessarily follow. So the answer would be able to force the questioner to retract this syllogismos claim and keep on going in the debate. For the valid moods, whatever objection opponent will raise, whatever objection the answer will raise against the syllogismos, the questioner will say, well, from what you have said, I can destroy your objection. So this is the link between dialectic and syllogistic. What the dialogical framework introduce, which I think is an important distinction, is this level between plays and strategies. So for valid syllogistic moods, there's a winning strategy. So that means whatever comes up, the proponent will be able to win. So the questioner will be able to impose the conclusion on answer. The play level is where argumentation really happens. So for the invalid moods, we stay at the level of the play level. So the opponent will be able to defend herself, which is the answer will prevent the syllogismos from impacting her. Now that's the level, so the idea is that prior analytics is at the level of strategies. For Aristotle, he found how to arrive at this level of strategies. Dialectic is the play level through and through, where we're discussing of like real life content with meaning, and so we're not at a formal level speaking of A and B and predicates and subjects, but we're talking of birds and walking and what is predicated of what, how it is predicated with all the predicables, and that's a level that's completely different. It would require maybe large language models, I don't know, but that's why I'm really interested by Antonis's work on dialectic and how to make that work. I have been working with linguists in Gothenburg, and Colin has been embarked into that project, trying to formalize topoi using, so they have type theory with records, which is a kind of type theory adapted to linguistic use. And it's challenging to find a formal way to explain generality and the generality of the topoi within the generality of language. So saying that we have to talk about a property that all crows have, and then say that this property is an essential property, or it's in a genus, and that's a meta level that requires already like a very sophisticated tools for language, and that's why linguists are good partners on that. So I admire a lot of people who work on dialectic.
Okay, one more question.
Thank you very much, Zoe. This is very stimulating. And actually, the question that I have is against the background of our work with the folks in Gothenburg who use type theory with records in the attempt to develop a non-extensional semantics, which is very fine-grained. And their operating hypothesis is sometimes that the meanings of speakers in contexts are so individual and so, shall we say, non-generalizable, that it's very hard to do the very thing that you're doing, namely extracting some general content that can be shared through the dialogue. My impression from working with these formal semanticists and computational semanticists was that sometimes they're just trying to preserve a very individual meaning formation in context. And that actually goes against some proof theoretical intuitions. So how do you deal with that? It seems like the sharper you make that non-extensional semantics, the harder it is to generalize across contexts.
I think that's why dialectic is a problem. Aristotle used dialectic because, well, with people around him, they know their language. And so from something we already have acquired, which is multi-layered and very complex, we can reflect on that and form rules. But the problem is when we try to formalize it, we have to rebuild the structure. And building the structure is difficult. So once we have the structure, then we can formalize general rules based on that structure. And the rules will have to, finding the solutions for the multi-layered approach is already a way of finding the solution for formalizing the general rules.
Okay, thanks for the talk, and let's thank the speaker again.
Ευχαριστώ πολύ. I'm very happy to be here and close this very interesting, in my opinion, conference. I want to thank the organizers, especially Dukas, for giving me the honor to give the final talk in this conference. So my talk is what you see here: can artificial intelligence reach human thought? In my opinion, you see, the more you think, the more you are impressed by the ancient Greeks. In that sense, in my opinion, it was a very good idea to have this conference with a title that was given, and in the Academy of Athens. Why? When we talk about this question, there are two concepts that immediately come to mind. One is thinking, and the other is machines. You see, both of them, in a sense, began with ancient Greeks. As you know, the main characteristics of the Greek thoughts were what? Quest for knowledge and admiration of beauty. The ancient Greek philosophers were the first to attempt to analyze the process of knowing, and especially they were first to think about thinking. They understood that the search for understanding requires methodologies which approach the hidden. I cannot think of a better way of expressing this fact by what Anaxagoras said. Phenomena are the side of the hidden. The Greeks also, in some sense, through the concept of automaton, already foreshadowed the discovery of robots. Therefore, now that robots are prevalent and artificial intelligence has reached astonishing level of effectiveness, the following question is naturally raised. Could robots surpass human thinking, resulting in their final domination over us? There is another reason that I supported this idea of Lucas and others to have this conference, because a fundamental aspect of the Greek thought is interdisciplinarity. And this interdisciplinarity is expressed by the fact that, as you know, for the ancient Greeks, there was no distinction between sciences and humanities. History, philosophy, law, and arts were all considered part of a continuum in which, of course, science was included. Does it make sense to have a conference with the title Aristotle in it when you talk about artificial intelligence? I believe the answer is yes. And I'm very impressed by the books that Schrödinger wrote. You see, if you're aware of the book of Schrödinger, Nature and the Greeks, it's a remarkable book. The statement of Schrödinger is very simple. What do you do if you get stuck? Remember, at the time, there was a crisis that gave rise, in physics, a crisis that gave rise to the general theory of relativity and to quantum mechanics, that Schrödinger played a crucial role. And Schrödinger asked, what is the best way to overcome the crisis? And his advice was fantastic. Return to the ancient Greeks. See? It is written here that the present crisis in modern basic sciences points to the necessity of revisiting its foundations down to the very early layers and to return once again to an assiduous study of Greek thought. I have been, of course, influenced by the Greeks, and in this book, Ways of Comprehending, which is being translated into Greek as Μονοπάτια Κατανόησης, I have attempted to follow this interdisciplinary approach of the Greeks, and as Antonio Damasio, who is maybe the best person in the area of feelings and emotions, summarized this basic question of we have to understand, we have to comprehend how we comprehend. And this is the main aim of this book. And this book has a subtitle, The Grand Illusion and the Essence of Being Human. And this subtitle is an attempt in this book to understand what is this grand illusion and what is that distinguishes us from our evolutionary predecessors. I had the opportunity to attend many of the very nice lectures in this conference, and parenthetically, in some of these lectures, this question arose. You see, because if you want to understand what is artificial intelligence, how do we differ from other animals, etc.? And of course, the obvious things were said, namely reason and language, etc. In my opinion, we differ from animals with respect to this second hypothesis. The second hypothesis claims that our main difference from our evolutionary predecessors is our predisposition to construct real versions of our mental images and unconscious structures, or if we cannot construct them, at least to give them specific symbols. And I have called these constructions meta-representations. Obvious examples of symbols are language and mathematics. And obvious examples of constructions are technology and the arts. And this is one of the main reasons why I'm so attracted, at least ideologically, to artificial intelligence, because artificial intelligence combines three of these most powerful meta-representations. Namely, artificial intelligence is the combinations of mathematics, computations, and technology. It provides the next step in the hierarchy of great human endeavors that began with writing and printing and continuing with computing and the internet. Very quickly, I will discuss the early history of artificial intelligence. It is necessary to put what is happening now into this perspective. In 1943, two electrical engineers mimicking, you see, almost everything in artificial intelligence is an attempt to mimic or motivated by how the brain works. This began in 1943 with this pioneering suggestion of two electrical engineers about neural networks. In 1958, in some sense, this was materialized. Rosenblatt suggested that the only way for the machine to think is to try to mimic what the brain does through the billions of neurons and trillions of their synapses. But he did something more important. He introduced a set of mathematical relations which dictate the function of or mimics the function of a single layer of neurons. In 1959, Samuel called this novel approach machine learning. So what is machine learning according to Samuel? It is if the input to a computer, to a machine, consists of a sufficiently large set of data, well organized, by the way, then the computer could be programmed to learn how to extract information from such a set. The emphasis on the word learn. This idea of machine learning had nothing to do with artificial intelligence of earlier times, which was based on logic algorithms. Namely, until then, the idea was to follow well-defined algorithmic steps. This type of logic-based algorithms are very efficient if the problem is well-defined, if you have rules like chess. But they were doing very poorly if the problem is not well-defined, for example, that is defining a face in a picture. You see? Unfortunately, the early attempts to use machine learning to solve the lateral problems failed. And as Kevin told us yesterday, that led to the well-known winter in artificial intelligence. And as he told us, it was at times embarrassing to say that you work in artificial intelligence. You see, this situation changed in the mid-80s. When what happened? Did we really have a new breakthrough? The answer is no. As Kevin said, all that happened is you went from one layer to two layers and many more layers, and then this way you arrived at deep learning. So what is deep learning? Deep learning is the process through which the information extracted from each layer is used as an input to the next layer. This form of artificial intelligence, called deep learning, allows the manipulation of particular features of the given data in such a way that useful information contained in the data can be identified and extracted in an efficient hierarchical manner. You see, in order to understand the difference between deep learning and the earlier attempts, it is important to understand the concept of computation. What is computation? Computation can be defined as the process of transforming an input to an output. And the heart of computation is specifying this transformation, how you go from the input to the output. And this is achieved through a mathematical creature which is called a function. The difference between earlier forms of artificial intelligence and later forms is that now artificial intelligence is much more dynamic. What it's meant by that? Earlier, this function was fixed, was static. So if you have a neural network, the weights of the neural network were fixed. But this is not how the brain works. Brain is characterized by plasticity. The most fantastic feature of the brain is plasticity, which means our brain continuously changes, which means synapses are not stable, change. And this is the idea which is mimicked by deep learning. So the neurons following neurons, when you see neurons in quotation, means artificial neurons following specific instructions are able to adjust their weights according to what they learn. And how they learn? They learn through the process of being trained. In 2022, exactly 10 years after the earlier development, there was a new breakthrough, maybe, I'm not sure if I would call it breakthrough, which is the appearance of the so-called generative artificial intelligence. So what do we have? We have this new class of models which exploit very simple fact. The fact is that language, data, are very well organized and are given in a sequential form. This means that a network, by training via reading extremely large number of sentences, is able to do what? To learn where do I pay attention. And after that, is able to make prediction. But there's now a huge advantage. I didn't mention before, what was the main reason that he had such a fantastic new results? As I said, there was not a new breakthrough, but there were many changes that had happened by then. The most important of them is our life had been digitized. So it was very simple to have infinite amount of data. Another reason, by the way, was that video games had produced these graphics which were crucial, cloud computing, which was discovered at CERN, as you know. All this affected this big revolution. But now, with a generative AI, we had a new ability to use data. There was no need anymore for supervised learning or having a good set of data. You could get all of Wikipedia, all of poetry, and use it as your data. By the way, a complexity of the system of any network is characterized by the number of parameters that specify these transformations. When GPT-3 was announced, they were kind enough to tell us the number of the parameters they use. And this is there, 175 billion parameters. No, they didn't disclose the number of parameters for GPT-4. I don't know this. However, it is known right now that the Chinese company Alibaba has networks which involve 10 trillion parameters. It's mind-boggling. Okay, achievements of artificial intelligence. You see, I have a whole chapter in my book, which is in print, where I discuss achievements, especially in medicine. You see, the first excitement was in games. As you know, AlphaGo beat the best person in this area, which was a fantastic achievement. Why it was a fantastic achievement? Because this game is not like chess, when you have rules. you needed intuition, etc. But still, not only AlphaGo beat the best player, but soon after AlphaZero trained itself by playing with itself and then beat immediately AlphaGo doing this. It's a fantastic story, I don't have to tell you, but if you look at their logic, it's very different than the one humans would follow. Another huge breakthrough in 2021, AlphaFold, as you know, the Cypriot got a Nobel Prize for this work. They were able to predict the 3D dimensional structure of millions of proteins. I know very well this problem. I have written with Gelfand and others 3 papers which were published in the Procedures of the National Academy of Science, and I know the complexity of this problem. If you just to mention a couple of things, in medicine, already artificial intelligence algorithms have been validated for diagnosing skin melanoma, diagnosing pneumonia by the analysis of chest X-rays, interpreting certain pathology slides, and evaluating diabetic retinopathy. And this is done right now as well as dermatologists, radiologists, pathologists, and ophthalmologists. In my opinion, precision medicine will not reach the level that it should without artificial intelligence. Why? Because, as you know, if you are a medical person, in precision medicine, you need to sequence not only the patient's DNA, but the tumor DNA, the same thing with RNA, with their immune status. You have to grow cancer cells in vivo and see how they are, how vulnerable they are to medicine. Already, IBM's Watson is concentrating on producing a program doing this. If you combine neuroscience with artificial intelligence, the results are unbelievable. You see, just one example, an array of electrodes implanted in the cortex of a patient who for 12 years was unable to walk through an accident, allowed researchers to monitor his brain activity. Then, and here is the huge contribution of artificial intelligence, they decoded this activity, and after doing that, they were able to implant electrodes to the spinal cord and send these signals, and this allow the spine to excite certain muscles, and the miracle took place. In 2023, this young man walked, my dear colleague. You see? Okay. Will artificial general intelligence be reached? This is the great dream of DeepMind, Open, artificial intelligence, Google, and some other leading companies. You see, there is, this is actually the main part now, come to the main part of my talk. You see, as you know, media like hype. And now continuously we hear about the tremendous achievements, which of course is true, but at the same time we rarely hear about problems, you see. Kevin was kind enough yesterday to tell us about the stagnation, for example. Why don't we have GPT-5? Because there is no more progress, essentially, at this level. Why there is no more progress? There is no progress because all the data has been exhausted, you see. Will there be a breakthrough? You see, you cannot say something will not happen. As some of you know, there was not really breakthrough for the last, I don't know, 50 years. It doesn't mean that there will not be a breakthrough tomorrow, especially since there is so much enormous investment in this area. On the other hand, there are some people, you see, who believe that this bubble will break. You see, for example, Luciano Floridi, who is at Yale, claims that it's too much investment, and indeed, that's why I say there the losses of OpenAI have reached already this year $5 billion. You see, so if this investment slows down, then I don't know if further breakthroughs or if breakthrough will take place. In any case, I believe much more Mustafa Suleyman about what he thinks is doable right now, this artificial capable intelligence. This means artificial intelligence will be able to weave together sequence of actions so that it can make long-term plans, such as those needed, for example, to run a company, and in some sense this is already taking place. I don't have time to discuss this. So, let me now come to the main part of my talk, which will not be long, and this is, can artificial intelligence reach human thought? You see, in this conference, emphasis was on Aristotle. In my opinion, this is not quite correct. The emphasis should also be on Plato. You see? Why Plato? Why Plato? For what I explained there, artificial intelligence, my dear friend Doukas, is the apotheosis of mathematics, algorithm, and the rational. It represents the strongest possible endorsement of key element of Platonism. Plato pushing the importance of the rational to its ultimate limit, claimed, erroneously in my opinion, that the only true reality consists of certain rational meta-representation. Meta-representation is my word. His disembodied forms are, according to him, the essence of things, whereas actual sensory experiences are simply shadows of reality. Don't forget that for Aristotle, stars are less important than their orbits. You see, because stars are perceived through our unreliable senses, whereas the orbits are the results of our impeccable thinking. In my opinion, in the same way that Plato elevated certain abstract notions above reality, some scholars have elevated reductionism and computability above the embodied brain and the astounding processes associated with it. An example, the MIT expert on robotics, Rodney Brooks, states, as a materialist reductionist, I agree with a claim of John McCarthy that every aspect of learning and any other feature of intelligence can be so precisely described that a machine can be made to simulate. I personally disagree with his dogmatic apotheosis of reductionism and computability, and I believe in an holistic approach. And in this approach, I think there are certain notions that are extremely important. Why? Something is important if and only if mimics what the brain does, such as associations, continuity, generalization, abstraction, reduction, etc. So with this framework of this holistic approach, let me examine if artificial intelligence can surpass human thought. First remark is, there is, in my opinion, question of methodology. And I think because a lot of you are philosophers and you are trained to think in a strict way, you will appreciate this point. You see, we knew that artificial intelligence did better than Kasparov, or did better than the expert on Go. But proving that a machine has surpassed the human level of intelligence would require a proof that for every conceivable human goal, the machine achieves better performance. It is apparent that this approach so far is only useful for specific cases. This suggests that unless a different methodology is introduced, the question of proving whether general artificial intelligence has been reached is what is called in mathematics not well posed, not well defined. Forgetting this point, let's go further. You see, many of the people that work in artificial intelligence are trained as physicists, computer science, mathematicians, therefore by definition they have good logic. One of them is Max Tegmark. So Max Tegmark understood the obvious thing, that if you are going to make comparison, you have to first define intelligence. What do you mean by intelligence? And he provided the definition there. According to Tegmark, intelligence is the ability to accomplish complex goals. If you read his book, you see that he compares this definition with the definition in the Oxford Dictionary, etc., and he proves that everything that the other definitions say is captured by this. I have a serious problem with this definition. I call this definition mechanomorphic. In the same way that in physics we make some conclusions which are anthropomorphic, which means we are biased as anthropy. In the same way, I believe that computer scientists or people that work in artificial intelligence are biased by their affinity with machines. As a matter of fact, I believe that with a slight modification, this definition is perfect for technology, which according to me is a collection of devices and engineering practices as means to achieve a complicated goal. I hope to convince you in a couple of minutes that actually this definition is the opposite of what human intelligence actually is. It's not that it's incomplete, it's the opposite. But before doing this, let me just talk about a couple of, you see, I will not tell you things which already you know. You see, I will not mention the fact that artificial intelligence can only do one thing when the brain can do more, common sense, things that everybody says. I will only mention a couple of things that are well known, and then I will try to present you what I believe are novel and powerful arguments. You see, of course, everybody understands that the machines have no understanding. You see, how do we understand? Conscious and unconscious associations establish relations on the basis of deep understanding of the underlying constituent parts. Our culture, but the only reason I put this here is to emphasize that this understanding is not static. Like nothing is static in the brain. Nothing is static in our culture. This understanding is continuously enriched as a result of our culture. Of course, the computer does not understand the meaning of this part. So there's a so-called Vinograph challenge test, and the computer cannot do well with that. So how would the computer understand what they mean in the following two sentences, Lucas? The city councilman refused the demonstration a permit because they fear violence, versus the city councilmen refused the demonstrators a permit because they advocate violence. Okay? The second thing that everybody also understands is implementation. The only reason I added this is for a joke, as you will see. So the process of implementing goals is obviously drastically different between machines and humans. The embodied brain shares with artificial circuits the ability to store and process information. But in addition, the brain creates subjective experiences. An individual, while achieving a particular goal, feels in a unique way an embodied fulfillment. The main reason I added this is to tell you that Kasparov, when he was beaten by Deep Blue, by the way, Deep Blue was not using deep learning, yes? We're using the old form of artificial intelligence. He was very happy to say, at least the Deep Blue was not enjoying beating me. Okay. So now, let me present some statements, some arguments, which I believe are novel. Incidentally, I asked the new form of GDP to answer the question I posed. Very disappointed with its answer. You see, none of what you will see from here on was included. And I'm shocked by the last part that was not included, which you will see in a moment. Okay, creativity. Now let me attack the definition given earlier.
you see. In my opinion, creativity is not defined in terms of achieving a specific goal. It is measured by the distance of the final unexpected achievement from a starting vague idea. Creative individuals, by establishing far remote associations, generate completely unexpected relations between different concepts. Until then, such notions had appeared so distinct that no one had thought of posing the goal of establishing a connection between them. The process of establishing such remote associations is crucially affected by unconscious processes and therefore much more difficult to be programmed. Summarizing, human creativity is non-literal and non-algorithmic. Sir Roger Penrose, Nobel Prize in Physics in 2020, many years ago, emphasized this non-algorithmic nature of breakthroughs. It is metaphorical, imaginative, and if you want to capture it in one word, in my opinion, the proper one word is transcendental. How does the brain do this? You see, how does the brain do this? Many people consider Johnny von Neumann the smartest person ever to live, smarter than Einstein, etc. Von Neumann was very impressed with various aspects of the brain, was impressed especially by the fact that it's very efficient, and understood already, although at the time neuroscience was not at the level which is now, that it is a massively parallel processor. Now we can substantiate many of these statements. You see, for example, now we know that a neuron consumes about 10 to the minus 9 watts, which is much more efficient than the transistor, which consumes 10 to the minus 1 watts. With respect to this unbelievable parallelism, the input to a given neuron, as you know, is achieved via its synapses. A type, I will come back to this. And there are neurons which have about 10,000 synapses. After integrating this input, the given neuron decides if it will fire, namely it will be activated or not. The parallel architecture means that all synapses can be active simultaneously. Therefore, taking into consideration that each synapse is active 100 approximately times per second, it means that the brain has the ability of 100 times 10 to the 14 synapses, 10 to the 16 operations per second. This is a huge number. Just by comparison, a modern desk machine can process 10 to the 9. But what is hugely important, that this is just one of the mechanisms that the brain uses. I will, if you look at chapter 10 of my book, I discuss several others. Here I will only spend a few minutes talking about glia. Okay, so let me tell you a few things that are completely ignored by the modeling of artificial intelligence and which are crucial for the way we think. The first fact is the obvious thing, the elephant in the room, that the brain is embodied. You see, I talked about associations. Why we have associations? We have associations because there is the appropriate connectivity in the brain. Associations are mainly based on one fundamental connectivity in the brain, which is reciprocal connectivity. And this is, for example, the most important such system is the thalamocortical system. Other parts of the brain use other type of connectivity. For example, the cerebellum, basic ganglia, and hippocampus use a parallel type of connectivity. But what I want to emphasize here, with respect to the embodiment of the brain, is a third type of connectivity. And this type of connectivity is diffuse, and if you want to think of it as a big fan, and it starts for certain nuclei. What is a nucleus? Nucleus is a collection of specific cells. And these nuclei take the name of what is produced by the cell. So, for example, there is a serotonic nucleus which produces serotonin, etc. Okay? So, this the brain produces certain molecules. But not only the brain. There are molecules which are produced in the brain which affect the body proper. Molecules which are produced in the body proper which affect the brain, and some both ways. Just to give you an example. By the way, neuromodulators is the name that's given to specific neurotransmitters which affect other neurotransmitters. Classic neuromodulators are dopamine and noradrenaline. How can you think of the function of the brain without taking into consideration these molecules? For example, as you know, dopamine is the molecule of pleasure, of anticipating pleasure, etc. Similarly with hormones. Just to give you an example, we know the importance of serotonin. My dear friend, Dr. Christodoulou is here. He knows that many of the patients that suffer from depression are given serotonin reuptake inhibitors, so they increase their serotonin. You would think serotonin is produced by the brain. No, 5% is produced in the raphe nucleus. 95% of serotonin is produced in enteric neurons. Just an example of the tremendous importance of the embodiment. Two more remarks. One is lateralization. The left and the right brain do different things. Again, I have an entire chapter in my book, so it's very difficult to summarize it in one transparent. Just very quickly. If you look at the left hemisphere, the first thing you will see is that it's less white. It has less white matter. It means it is less globally interconnected than the right hemisphere, which is the reason why the left hemisphere is great at doing things locally. By the way, again, Professor Christodoulou knows that if you saw a schizophrenic, a painting which consists of fruits but is a face, will not tell you that she's a face. Will tell you that she's bananas, etc. Because concentrates locally, because they're hyperactive on the left hemisphere. That's why the left hemisphere is very good at reduction. The right hemisphere is the opposite. The right hemisphere takes a gestalt approach. There is, and because unconscious processes use far remote associations, the right hemisphere is much better for these processes. Just to give you an example, by the way, and this is why it is so practical. I'm trying to think a name, I concentrate, Regina, what is the name? I don't remember, I cannot think of this. Then a little bit later, you remember. Why you remember? You remember because when you think, when you concentrate, your left hemisphere is active, which means you make only local associations. But the best way to remember something is to make global associations, and this is what happens when the activity moves to the right hemisphere. You see, mathematics, science, medicine, technology are crucially dependent on the employment of algorithms and the use of tools. So many investigators have erroneously, in my opinion, claim that all these are the result of the left hemisphere. You see, the brain was created after billions of years of evolution, so it's extremely clever. It could not do this. Everything has complementarity. For example, deep inside, which is very important in mathematics, etc., in science, is achieved in the right hemisphere. You can see this in language. Although language begins in the left hemisphere, the crucial understanding of the meaning, so semantic understanding, emotional significance, metaphors, etc., are the result of right hemisphere. I'm almost done, but I want to tell you something about glia. Glia has become one of my favorite subjects, you see. It gives me the opportunity to again come back to Aristotle. Aristotle said, nature does not create anything useless. You see, the ratio of glia to neurons is 6:1. Can you imagine? But despite of that, I have never heard any artificial intelligent person talking about the glia cells. But they want to mimic the brain. How can you mimic the brain without talking about the glia cells? Of course, they have a very serious excuse. The serious excuse is that even up to 10, 15 years ago, nobody talked about glia cells. But now, despite the fact that already Nansen, Nobel Prize in 1922, he was a fantastic, by the way, scientist, humanist, etc. Nansen told us about glia cell. What did he observe? He observed something very simple. He was an anatomist also. He observed that the more you go up the evolutionary tree, the more the ratio of glia to neurons increases. So he made already, at that time, the audacious statement that glia is the seat of intelligence. You see? Diamond at Berkeley has had the privilege of analyzing the brain of Einstein. What was found? It was found that in the parietal and inferior lobule, which is the area where mathematics and other things take place, Einstein had a unique advantage to all of us. The advantage is, you see, the ratio of glia to neurons changes according to the area. In this area, we have ratio 1:1, glia to neurons. But Einstein had 2:1. You see? I cannot tell you a lot about glia. I hope you will be able to read this as a whole chapter in my next book about glia. But I will only tell you the following. You see, I mentioned earlier the communication through synapses. Okay? This communication is what? Is fast, specific, and local. The communication achieved through glia is exactly the opposite. It is slow, it is non-specific, and it is global. I say something about how slow it is. With respect to global, I should say the importance of propagation through calcium waves. So in some sense, you see, one should never be obsolete. If you have read the history of neuroscience, it is summarized in my first book, the contrast that there was between neurocists and reticulocysts. The reticulocysts thought that the brain was there was a network. In some sense, glia cells provide such a network. In some sense, they were right. Finally, and this was for me the big shock that when I asked GPT about it, it was never mentioned, is the limitation of mathematics and the machines. You see? How is mathematics built? Mathematics starts. I have one more image. How is mathematics built? Mathematics starts from a set of axioms, and then with very simple algorithmic steps, you build, and you build these fantastic structures. See? Therefore, you would expect, like the great Hilbert expected, that you can go backwards. You start from up there and you come down. And actually, Hilbert thought that he had proven this result. You see, this is the axiomatic approach of Hilbert. And then Gerd Gödel comes and proves this fantastic theorem that this is not true. Namely, there are infinitely many correct mathematical statements which cannot be proven. You cannot go backwards. You see? This was a shock to mathematics. I will only tell you that Harvard gave an honorary degree to Gödel with a citation, the most important result in mathematics in the last 100 years. But, and here is again why Aristotle should be mentioned. I believe Aristotle understood that nous, actually it could be given as a definition of nous. Nous has the ability to intuitively understand the correctness of axioms. Indeed, many of these mathematical propositions, which cannot be proven mathematically, we intuitively understand that they are correct. It means our consciousness is larger than mathematics. Turing, under the influence of Gödel, tried to prove a similar result for his Turing machine. And he showed that indeed, there is something analogous to incompleteness theorem. Lucas has written a very nice paper, which has not been as recognized as it should, where he shows that there is a function called Ackermann function, which although cannot be computed through a Turing machine, can be computed through an ideal person. Okay, this means what? This means that, you see, artificial algorithms are based on the conscious function of parts of the cerebral cortex. But every conscious experience is preceded by an unconscious process. So what I want to say before is that this shows that our conscious is bigger than mathematics, computer science, therefore artificial intelligence. But there is another aspect, and these unconscious processes. One of the main things emphasized in my book is that, first of all, not only there are no conscious experience which is not preceded by an unconscious process, but more importantly, the passage from the unconscious to conscious when it happens, because many times, most of the times, it doesn't happen, but when it happens, it is not only slow, but it loses information. That's why I always say our brain knows much more than we know. So the human thought is created via the interaction of conscious and unconscious processes in the dynamic environment of the embodied brain. It is crucially affected by hormones, neuromodulators, the glia, and a variety of unconscious processes. Finally, I spoke very much in my book about meta-representations. Meta-representations and culture are hugely important and have been completely ignored. Let me finish this talk by saying that everything I said is under one disclosure. The disclosure is that you don't have synergy or combination of silicon with neuron. If this happens, then everything I say has to be viewed differently. But because I don't want you to think that I am biased against artificial intelligence, let me complete this talk with something very important, which I believe has been also not emphasized enough. You see, a key component of learning is the continuous elaboration of associations. They are of crucial importance for deciphering relations between different entries, and this is how understanding is facilitated. Deep learning, by analyzing huge set of data, has the capacity to establish opaque associations which are hidden to the human mind. By exploring this information, the new artificial intelligence systems identify patterns and hidden relations in data. Harnessing these relations, artificial intelligence can solve complicated problems. This is a new type of intelligence which manipulates a reality hidden to the human brain. Will we understand how this is done? Will we be able to decipher the process that artificial intelligence uses? Despite the fact that I'm an optimistic person, the answer, in my opinion, is no. Any system that consists of trillions of parameters is impossible to be understood. This is terrible because we lose the opportunity to learn something new. People that follow artificial intelligence know that there are some things which are mind-boggling. You see, in AlphaGo, this famous move 37 that nobody could predict. You see, in AlphaZero, the queen was sacrificed. Completely crazy, you see, which means, in my opinion, artificial intelligence has creativity. Can we learn? It seems we cannot. And this is terrible. In any case, I want to complete my talk with a statement that mature scientists should avoid hype, and even when they know that there are questions which cannot be answered, like, for example, this question, how artificial intelligence reaches its conclusions, a mature scientist dedicates his or her life to searching with a hope that a little bit of progress will be made. And if they are lucky, there will be a breakthrough. And then they will feel this feeling which the ancient Greeks again expressed in the best possible way, eudaimonia. And at the same time, as soon as they feel eudaimonia, immediately I think an association will be made with feeling awe. At what? At the incredible inventiveness of nature, and especially of its greatest creation, which in my opinion remains the human brain. Thank you very much.
Okay, thank you so much.
I leave that on. Okay.
Okay, thank you so much for the talk and for closing this conference. So now they have...
There was some reference which should stay on, but somebody didn't. Okay. While you're doing that, maybe there are questions.
Yeah, okay, so, yeah, please. Professor Zelepidis, yeah.
I hugely enjoyed your talk.
Very kindly. Thank you very much.
We seem to disagree in a couple of points, but there's no time for discussion on this. Now, the point I wish you to comment on is a point of information which extends your point concerning the significance of glia cells. Now, we all know that mitochondria is the energy factory, but we thought that they are static. Actually, it was found that they are not static. They move from one cell to another. And out of the three possible ways, one of them is by a tunneling nanotubule. Now, that may not be the case, maybe freely floating, etc. Now, I would like you to comment on this possibility as far as your point about glia cell is concerned.
You see, I didn't understand very well the question, but what I can say is that a horizontal gene transfer is a fantastic way of that evolution works, and I speak a lot about that in my book because it completely goes completely beyond what Darwin and Wallace thought evolution was. You see, I always consider evolution not as a theory, but as maybe a way of thinking. A theory should be predictive, and the dogma or whatever of evolution is not. But despite of that, I think what is important, I could talk a lot about gene transfer. As you know, in 1977, a new type of life was discovered. Archaea is called. Nobody thought there was a new type of life, but there is. And actually, archaea is very important because apparently the first cells which accepted mitochondria were archaea. But this is details. What I think is very important is to understand that evolution had the advantage of time, billions of years. And this is why you see this complexity. If I wanted to persuade people that God exists, I would use as example physics. Because in physics you have this miracle. You have very simple laws, elegantly expressed in the form of mathematical equations which dictate everything. Only God could have done that. If I want to disprove the existence of God, I would use evolution. Because evolution, if I was God, I would make a person. But this is not how a person was made. It was made through trial and error, going. And this is the reason for complexity. This is the reason for what I call redundancy, why we survive more. Because as medical doctors know, if something fails, there's something else which used to be before, etc. So evolution had time on its hands and created, finally, very effective solutions. If you want to do artificial intelligence, okay, mimic the brain, but mimic it completely. The approaches so far are completely fragmented, in my opinion, completely inadequate to reach what the brain does. So I am even, how can I say, shocked by the fact that many people believe singularities approaching and all these things. This, in my opinion, is fantasy. But I might be wrong, of course. Keep this in mind. I don't work in this area, and I might be wrong. But this is my opinion.
You're right.
I cannot hear.
Okay, can you hear? Okay, thank you.
Yeah, I can hear you. Thank you.
So, I have a point of information about the new quantum computing that Microsoft has just discovered. How this is going to change, in your opinion, the space of artificial intelligence, and will it even reach human comprehension at this point? Last question, last part of the question: can with this can we simulate the neuromodulators and all the hormones that you mentioned previously? Okay, thank you.
I didn't hear the second question. I'm sorry.
No, if with this technology.
I understand.
Yeah, yeah.
Okay. Okay. You see, of course, quantum computing is. If you want to worry about something, I wouldn't worry about artificial intelligence, but I would worry about quantum computing. Because if this is indeed achieved, as you know, immediately all security is dead. Okay? Of course, you might say that the society usually solves the problems it creates. And indeed, as you might know, the Chinese have established now quantum computing-based communications, which are unbreakable. So maybe the same mechanism that will allow you to break any code will again protect it, but I'm not sure. I believe that quantum computing is a very, very serious possibility, and this will have a much, much more devastating, if you like, effect than artificial intelligence. To what extent quantum computing will allow us to do things now, to go to the next level of artificial intelligence, I'm not sure, because I don't work on quantum computing, but if I am scared about anything, it's not artificial intelligence, but it is quantum computing. So your question is absolutely, absolutely important. No, that's it.
Thank you very much. I should like to ask a question regarding your presentation. At the beginning, you said that creativity is a unique human feature because it's based on the capacity of the brain to create very far remote associations. At the end, you said that artificial intelligence is creating a lot of association hidden to our brain, which means that artificial intelligence is very creative.
No,
Could
you see, because I know your IQ, which is 158, it doesn't surprise me that you made this question. This is absolutely correct, but it has there is a logical fallacy. You see, I said one of the features of creativity is creating remote associations. It's not everything, but still, I say that artificial intelligence makes associations because this is the closest I can come to what it's done. But I don't know how artificial intelligence is able to extract the information from data which to us are opaque. But I only want to emphasize, I emphasized earlier, that this is very unfortunate that not only we don't understand now, but I think proponents of artificial intelligence agree that we will never understand. And this is because we will not learn from this creativity. You see, I worked for many years on the problem of protein folding, 3D protein folding. What is the problem? The problem is you give the sequence of amino acids and you want to predict its three-dimensional structure. Finally, as I told you, we wrote 3 papers in the proceedings of the National Academy of Science, and we came up with some topological rules. And these topological rules were used by a group at Princeton of Ludas to make prediction for a specific, not every protein, for a specific class of proteins called sandwich proteins with accuracy of 85%. Okay? Now, this work is absolutely obsolete because for millions, not only sandwich proteins, but for millions of proteins, you can predict its three-dimensional structure. Nobel Prize, absolutely well-deserved. But there is a question. What have we learned from this? You see? In my opinion, we have the practical answer, but we haven't learned anything about how nature worked in order to do it. At least in our incomplete work, we know that there are certain topological rules which are very important. This is why I'm very frustrated, if you want, that we cannot decipher how artificial intelligence works.
So we'll take a last question. No, you no longer want to. Yeah. Okay, so you won't put your question.
Let's have a lady.
Okay.
Let's have a lady have the last question.
Professor Focas, thank you, De Profundis, for this very challenging presentation and all the results you showed us on the difference between the human brain and, of course, the artificial intelligence. And the question, can the artificial intelligence be creative, capable?
Can it be creative?
Capable.
I don't understand.
You told us that the goal is to find an artificial intelligence capable, not only generative.
Yeah.
Okay. So I would like to pose this question. We know from the preschool-age children and very many studies of neuroscience that the human brain creates its basic neuron networks up to 6 years old through a process that is called pruning. And of course, little children really surprise us with what they can do from the very early years, either in creativity or in initiative or in other things of intelligence. So maybe there are scientists that already study this pruning procedure that happens in the human brain. Do you have any information on that?
No. You see, of course, I know pruning very well, but this is, you see, in my opinion, I always view pruning as the first or the most important, early important part of what I mentioned already in my talk, of the huge ability of the brain for plasticity. I forgot to mention that these neuromodulators and hormones are very, very important also for plasticity. So this is a property that we have, which creates everything. And in some sense, what happens with artificial intelligence is an endorsement of the ingenuity of the brain. The reason why earlier artificial intelligence failed and the new artificial intelligence is so successful is because now it mimics this fact that synapses change both quantitative and qualitatively according to what they learn. That at least model this part with allowing the weights to change. So, and there are other examples. So, in my opinion, pruning is important, but it's only one type of plasticity. I think we finished? No. Okay. Thank you very much. Thank you. Thank you. Thank you. Thank you. Thank you very much.
Here it is. We have a present for you. Please.
So, dear participants of our conference, dear distinguished leftovers from this morning's sessions. So I was volunteered to briefly report on a workshop on the topic Pons Asinorum, which was organized as a kind of appendix to the big conference, or as I would prefer to say, as a prelude to the conference. And the Pons Asinorum refers to a theorem in Aristotle's logic. Pons Asinorum is meant to be a donkey's bridge, because donkeys are undeservedly supposed to be very stupid. And by this bridge that Aristotle builds for donkeys, even not so intelligent users of Aristotelian logic are meant to be able to build arguments. And the word donkey's bridge, or Pons Asinorum, was invented by Petrus Taretus in the 15th century. You can also look it up under the notion of inventio medii. Medii refers to the middle term of a Aristotelian syllogism. A belongs to B, B belongs to C, A belongs to C, so B is the middle term. And this Pons Asinorum is meant to refer to a technique how to find the middle term for each and every conclusion, such that we can deduce this conclusion from a set of premises. What is the connection with the topic of artificial intelligence? Well, the concern behind this Pons Asinorum is how can this process of finding the middle term be mechanized, as it were, so that the finding of the middle term does not depend on the user's ingenuity, intelligence, not on her form on the day. Such an algorithm machine is indeed the precondition for the computational use of Aristotle's syllogistics. And in this workshop, we heard presentations by Colin King, Dukas Kapantais, Sui, McCorney, and Marco Malink on the 4 chapters of the prior analytics, of Aristotle's prior analytics, that deal with this technique. You are certainly not interested to hear the details of this technique. So I just summarize by saying that, to my mind, and I was not among the presenters, considerable progress was made with regard to the reconstruction of this technique, with regard to the formalization and illustration of this technique, and also with the relation of the logically valid deduction to the explanatory demonstrations, because it turned out in the course of the discussion of these chapters that Aristotle does not only think that with this mechanical form of building syllogisms we can find premises for a valid conclusion, but that he also thinks that this is already the key to building scientific demonstrations such that the premises are explanatory of the phenomena mentioned in the conclusion. And so, with all due respect, we find that this attempt towards mechanization of thought and computation of thinking can be better found in Aristotle than in Plato. Thank you very much.